Rails for Real. Build your first web applications with Ruby on Rails. Chapter 1, Ruby, the language under the Rails. You're about to embark on an exciting journey into web development with Ruby on Rails, a framework renowned for its speed, elegance, and ability to help you build powerful applications surprisingly quickly. But before we dive into the Rails part, it's essential to understand the foundation upon which it's built, the Ruby programming language. Think of it this way. If you're learning to drive a high-performance car, it's helpful to know a little about the engine that powers it. You don't need to be an automotive engineer to drive, but a basic understanding of how the engine works will make you a more confident and capable driver. Similarly, you don't need to become a Ruby language expert overnight to master Rails, but having a grasp of its core principles will make your Rails journey smoother, more intuitive, and far more rewarding. Why Ruby? The philosophy behind the language. Ruby was created in the mid-1990s by a Japanese computer scientist named Yukihiro Matsumoto. His primary goal was to make programmers happy. Seriously. Unlike many languages born from academic research or corporate needs, Ruby was designed with developer productivity and joy as central tenets. Mats famously stated, "I believe that the purpose of programming is not to make machines happy, but to make human beings happy." This philosophy manifests in Ruby's highly readable, expressive, and often elegant syntax. It prioritizes clarity and convention, allowing developers to write less code to achieve more functionality. This focus on developer happiness is precisely what attracted David Heinemeier Hansson, DHH, to Ruby when he was developing Basecamp, the project management tool that eventually gave birth to the Rails framework. Rails inherited Ruby's emphasis on productivity and convention over configuration, making it one of the most efficient tools for rapid web development. So, let's explore some of the fundamental concepts that make Ruby such a delightful and powerful language. Ruby's basic building blocks, data types and variables. In programming, we constantly work with data. This data can come in many forms: numbers, text, true-false values, and collections of other data. Ruby, like most languages, has ways to represent these different types of information. Imagine you want to store someone's age, their name, and whether they are an adult. Numbers. For whole numbers like age or decimal numbers like a price, Ruby uses numerical types. For instance, you could store the age of 30 as simply 30. Strings. For text like names, addresses, or descriptions, Ruby uses what it calls strings. You'd represent someone's name, Alice, by enclosing it in quotation marks like Alice. Ruby makes it easy to combine or manipulate strings. For example, to say "Hello, Alice," you could combine the string "hello" with the string "Alice." Booleans. For true or false conditions, Ruby has true and false. If you wanted to indicate whether someone is an adult, you'd use true or false. To hold these pieces of data, we use variables. A variable is like a named container that can store a value. In Ruby, assigning a value to a variable is simple. You just write the variable's name, followed by an equals sign, and then the value. For example, to store the age of 30, you might write age equals 30. To store a name, name equals Alice. And for the adult status, isadult equals true. Once stored, you can use these variable names throughout your program to refer to their values. Ruby also provides powerful ways to group data. Arrays. An array is an ordered list of items. Think of it like a shopping list: milk, eggs, bread. You can access individual items by their position, starting from 0. So milk would be at position 0, eggs at position 1, and so on. Hashes. A hash, sometimes called a dictionary or map in other languages, is a collection of key-value pairs. Think of it like a real-world dictionary where you look up a word, the key to find its definition, the value. In Ruby, you might represent a person's details in a hash like this. Name: Bob, age, 40, occupation. Engineer. Here, name, age, and occupation are the keys, and Bob, 40, and engineer are their corresponding values. Keys in Ruby hashes are often represented as symbols, which are like lightweight, immutable strings often used for identifiers. Directing the flow, control structures. Programs aren't just lists of instructions, they need to make decisions and repeat actions. This is where control structures come in. Conditional statements, if else. These allow your program to execute different code based on whether a condition is true or false. Imagine you want to greet someone differently based on whether they are an adult. You could say, if is adult is true, greet them formally. Otherwise, greet them casually. Ruby's syntax for this is straightforward and reads almost like plain English. You write if followed by your condition, then the code to run if true, and optionally else followed by code to run if false. You can also add else if for multiple conditions. Loops, each. Often, you'll want to perform the same action on every item in a collection. The each method is one of Ruby's most common and powerful ways to do this. If you have an array of names, Alice, Bob, Charlie, and want to print a greeting for each, you would tell the array to each name in the list. Do an action like printing hello followed by the name. This method takes what Ruby calls a block of code, which we'll discuss next. Everything is an object, Ruby's object-oriented nature. One of Ruby's most powerful concepts, and central to how Rails works, is that everything is an object. Numbers are objects, strings are objects, even true and false are objects. This means that every piece of data in Ruby comes with its own set of behaviors and properties, which are called methods. Think of a real-world car. A car has certain characteristics. Its color, its make, its model, and certain actions it can perform: start, stop, accelerate. In object-oriented programming, a class is like the blueprint for a type of object. For example, a car class defines what all cars have in common and what they can do. An object or instance is a specific item built from that blueprint. A red Honda Civic is an object derived from the car class. Methods are the actions an object can perform. So, start and stop would be methods of a car object. Instance variables are pieces of data unique to a specific object. The color red would be an instance variable of our red Honda Civic object. These variables in Ruby are prefixed with an @ symbol, like at color. Let's imagine our car example in Ruby. You would define a car class. Inside this class, you might define how a new car is created. Perhaps it needs a color to be specified. Then you define methods like start and stop. When you want a specific car, you create a new instance of the car class. So you might have a variable myred car which holds a brand new car object that is red. Then, you could tell that specific car to start by calling its start method, like saying myred car start. The car knows how to start itself. This self-contained nature of objects, combining data and behavior, is a cornerstone of Ruby and, consequently, Rails. All the models in Rails, which represent your application's data, like a post in a blog or a user, are essentially Ruby objects. Blocks, Ruby's elegant chunks of code. We briefly mentioned blocks when talking about the each method. Blocks are truly fundamental to Ruby and are used throughout Rails. A block is essentially a chunk of code that you can pass to a method. It's like sending special instructions along with a request. You typically see blocks defined using the keywords do and end, enclosing the code you want to execute. Sometimes, for very short blocks, you'll see curly braces and instead. When you write array of names, each do name, end, the each method takes each element from array of names one by one. For each element, it temporarily stores it in the name variable, the one between the pipe symbols, and then executes the code you've provided inside the do end block. This flexibility allows Ruby methods to be incredibly powerful and expressive, letting you customize their behavior without having to write many different versions of the method. You will encounter blocks constantly as you work with Rails. Your first Ruby tool, the Interactive Ruby Shell (IRB). Before we even touch Rails, it's worth getting familiar with a simple but powerful Ruby tool, the Interactive Ruby Shell, or IRB. It's essentially a playground where you can type Ruby code one line at a time and see the results immediately. This is invaluable for experimenting with Ruby concepts, testing small snippets, or just getting a feel for the language without setting up a full program. To open IRB, you typically just open your computer's command line or terminal application and type herb, then press enter. You'll see a prompt, usually something like herb main 0010. At this prompt, you can type any Ruby expression, and when you press enter, IRB will evaluate it and show you the result. To exit IRB, you can type exit and press enter. We'll use this tool to confirm our Ruby installation in the next chapter. The influence of Ruby. Ruby's influence, particularly through Rails, extends far beyond just these two technologies. The concept of developer happiness, the emphasis on convention, the power of its object model, and the use of expressive syntax have inspired many other languages and frameworks that came after it. For instance, aspects of Python's Django framework, Node.js's Express, and many other modern web development tools carry echoes of the paradigms that Ruby on Rails popularized. While web development has evolved, Ruby and Rails remain highly relevant, stable, and continuously innovating, driving forward the very best practices in software development. Moving forward, this brief introduction to Ruby has armed you with the essential concepts to understand the language that underpins Rails. You now know about its data types, how variables store information, how programs make decisions and repeat actions, and the fundamental idea that everything is an object in Ruby. This conceptual groundwork is crucial because Rails masterfully leverages these Ruby features to provide its magical productivity. In the next chapter, we'll put this knowledge to practical use. We'll guide you through setting up your complete Ruby on Rails development environment, ensuring you have all the necessary tools installed and ready to start building your first application. Get ready to turn your computer into a web development powerhouse. Chapter 2, Getting Started, your Rails development environment. Now that you have a foundational understanding of Ruby, it's time to prepare your workspace for building impressive web applications with Rails. Setting up a development environment can sometimes feel like a daunting task, especially for newcomers. Don't worry, we'll walk through it step by step, explaining not just what to do, but why you're doing it. By the end of this chapter, you'll have a fully functional Rails environment, ready to create your very first application. Why a development environment? When you build a web application, you typically don't work directly on a live website. Instead, you create a local copy of your application on your computer. This local copy, along with all the software tools required to run it, constitutes your development environment. Working locally allows you to experiment freely, test new features, and fix bugs without affecting real users or risking a live website. Once your application is polished and ready, you then deploy it to a production server, making it accessible to the world. We'll cover deployment later in the book. For a Ruby on Rails development environment, you'll need a few key components. Ruby, the programming language, of course. A Ruby version manager to easily install and switch between different Ruby versions. Bundler, a tool to manage your application's Ruby library dependencies. Rails gem, the Rails framework itself installed as a Ruby library. A database to store your application's data. Let's start with the most crucial piece, Ruby itself. Step 1. Install a Ruby version manager. You might wonder why we don't just directly install Ruby. The reason is that web development projects often rely on specific versions of programming languages and libraries. Sometimes, one project might need Ruby version 2.7, while another requires Ruby 3.2. Installing a Ruby version manager allows you to painlessly switch between these versions for different projects, preventing conflicts and saving you a lot of headaches down the line. While there are a few excellent options, rbenv on Mac OS Linux and Ruby Installer on Windows are highly recommended for new developers due to their stability and ease of use. Option A. Mac OS and Linux using rbenv. rbenv is a lightweight and powerful tool for managing Ruby versions. Install rbenv, Mac OS, open your terminal application. If you don't have Homebrew, a package manager for macOS, installed, you'll need to do that first. Visit brew.sh for instructions, which usually involve running a single command. Once Homebrew is installed, run brew install rbenv Ruby build. Ruby build is an rbenv plugin that allows rbenv to compile and install different Ruby versions. Linux. The instructions vary slightly depending on your Linux distribution. Generally, you'll need to install Git and other build dependencies first. A common approach is sudo apt update, sudo apt install git curl hash for Debian/Ubuntu, hash for Fedora CentOS, use dnf install or yum install, curl fs/sl https, github.com/rbenv/installer/raw/head/bin/rbenv-installer bash. Self-correction for audiobook suitability. Avoid the explicit curl command. Instead, recommend. For Linux, follow the instructions on the official rbenv GitHub page, which typically involve installing Git and other build tools, then using their installer script. Configure your shell. After installing rbenv, you need to add it to your shell's configuration file, e.g., bashrc, zshrc, or bash profile, so it loads every time you open a new terminal window. This tells your system where to find the rbenv commands. Echo, eval, rbenv init, /, bash profile hash or /, zshrc or bashrc depending on your shell. Source /, bash profile hash or /, zshrc or bashrc to apply changes immediately. For audiobook, after installation, you'll need to configure your shell to activate rbenv. This usually involves adding a line to your shell's profile file, like bash profile or zshrc, and then reloading that file. Detailed instructions are available in the rbenv documentation. Option B, Windows using Ruby Installer for Windows. Ruby Installer is the recommended way to get Ruby and its development tools on Windows. It's an executable installer that streamlines the process. Download Ruby Installer. Go to rubyinstaller.org/download/. Choose the recommended version. Download the Ruby plus DevKit version that is marked as recommended. The DevKit part is crucial as it includes the necessary build tools for many Ruby gems. Run the installer. Accept the license. Ensure the checkbox for Add Ruby executables to your path is selected. This is vital as it allows you to run Ruby commands from any directory in your command, prompt, or PowerShell. Accept the default installation location. After installation, a command prompt window will open with the MSYS2 Development Toolchain installer. Press Enter to accept its default options when prompted. This installs the compilers and libraries needed to build many Ruby gems, including those used by Rails. Step 2. Install Ruby. Now that your version manager is set up, you can install the specific Ruby version that Rails requires. Rails typically works best with the latest stable Ruby version. As of this writing, a common choice would be Ruby 3.2x or later. Check available versions, rbenv users. Rbenv install L. This will list all the Ruby versions you can install. Install your chosen Ruby version. Rbenv install 3.2.2 # replace 3.2.2 with the latest stable Ruby version you choose. This can take a while. For audiobook, install your chosen Ruby version. For rbenv users, this is typically rbenv install, followed by the version number, like 3.2.2, 3.2.2. This process can take several minutes, as it's compiling Ruby from source. Set the global Ruby version. Rbenv global 3.2.2 # again, use your chosen version. This tells rbenv to use this Ruby version by default for all your projects. You can always override this for individual projects later. For audiobook, set this installed version as your global default Ruby. For rbenv users, it's rbenv global followed by the version number. Verification. Open a new terminal or command prompt window to ensure your system picks up the changes and run. Ruby V. You should see output similar to Ruby 3.2.2 PNNN, some date, architecture. Confirming that Ruby is installed and your system is using the correct version. Step 3. Install Bundler. Bundler is a critical tool in the Ruby ecosystem. It helps manage your applications, gems, Ruby libraries. Every Rails application will have a gem file that lists all the specific gems and their versions that the application needs to run. Bundler then ensures that everyone working on the project and the deployment server has the exact same versions of those gems, preventing compatibility issues. Install Bundler globally with your newly installed Ruby. Gem Install Bundler. For audiobook, install Bundler globally by running gem install Bundler. You might see a warning about not trusting all sources. You can generally ignore this for standard installations. Verification. Bundler V. You should see output similar to Bundler version 2xx step 4. Install the Rails gem. Finally, it's time to install Rails itself. Rails is distributed as a Ruby gem. Gem install Rails. This command downloads and installs the latest stable version of the Rails framework and all its dependencies. This might take a few minutes, as Rails is a large and comprehensive framework with many components. Verification, Rails V. You should see output like Rails 7xx, confirming that Rails is installed. Step 5. Choose and prepare your database. Rails applications need a database to store their data. For development, Rails defaults to using SQLite, a simple, file-based database that doesn't require a separate server. It's excellent for getting started because it works out of the box with minimal setup. When you use the Rails new command we're about to explore, it configures your new application to use SQLite by default. For production applications, or if you plan to share a database with other services, you'll likely use a more robust database like PostgreSQL or MySQL. These require separate server installations. For the purpose of this book, SQLite will be perfectly sufficient for our development environment throughout many chapters, and we'll discuss switching databases for deployment later. If you are following the Ruby installer for Windows path, SQLite is often already set up. macOS and Linux systems typically have SQLite pre-installed as well. You generally don't need to do anything specific at this point besides ensure it's available. Step 6. Create your first Rails application. The moment of truth. With all the pieces in place, you can now generate your first Rails application. Navigate to the directory where you want to store your projects using your terminal or command prompt. For example, you might create a projects folder in your home directory, mkdir /projects, cd /projects. Now run the Rails new command, followed by the name you want to give your application. Let's call our first app MyFirstApp. Rails new MyFirstApp. This command does a lot of work. It creates a new directory named MyFirstApp. It populates this directory with all the standard Rails files and folders, setting up a default structure for your application. It configures your application to use SQLite as its development database. It runs bundle install behind the scenes, which reads the gem file it just generated and installs all the specific gem dependencies your new Rails application needs. This process can take a few minutes. You'll see a lot of output scrolling by, indicating files being created and gems being installed. Step 7. Explore and run your application. Once the Rails new command is complete, change into your new application's directory. cd MyFirstApp. Now let's start the Rails development server, Rails server, or more concisely, Rails S. You'll see output indicating that a web server is starting up. It will usually say something like listening on HTTP 127.0.0.1:3000. This address, HTTP 127.0.0.1:3000, refers to localhost, your own computer at port 3000. Open your web browser and navigate to HTTP localhost 3000. Congratulations, you should see the default Rails welcome page. This confirms that your Rails application is running successfully. It's a simple page, but it signifies a huge step. Your development environment is fully operational. To stop the Rails server, go back to your terminal window, where Rails S is running, and press Ctrl+C, Command+C on macOS. Understanding the Rails application structure, briefly. When you ran Rails new, you saw a flurry of folders and files being created. Don't feel overwhelmed. For now, let's highlight just a few key directories you'll often interact with. App. This is where your application's core logic resides. It contains subdirectories for models, views, and controllers, the MVC pattern we'll discuss in the next chapter. Config/ contains configuration files for your application, such as database settings, database YAML, routing rules, routes.rb, and environment-specific settings. db/ stores your database schema and migration files. Gemfile. This file, located in the root of your application, lists all the Ruby gems, libraries, your Rails application depends on. When you run bundle install, Bundler reads this file. You'll get intimately familiar with these directories as we build our application throughout the book. What's next? You have successfully set up your Rails development environment, installed all the necessary tools, and even run your first Rails application. This is a significant accomplishment and the foundation for all the exciting things to come. In the next chapter, we'll dive into the heart of Rails, its philosophy and architectural pattern, Model View Controller, MVC. Understanding MVC is key to effectively building with Rails. as it provides a structured way to organize your code and clarifies how different parts of your application communicate. Get ready to understand the magic behind Rails organization. Chapter 3, the Rails Philosophy and Architecture, MVC Explained. You've installed Ruby, configured your environment, and successfully launched your first Rails application. That default welcome page you saw in your browser might have felt a bit like magic. In this chapter, we're going to demystify that magic by exploring the core philosophy and architectural pattern that underpins every Rails application. Model View Controller, or MVC. Understanding MVC is paramount to becoming an effective Rails developer. It provides a clear blueprint for organizing your application's code, making it modular, scalable, and easier to maintain. Once you grasp MVC, you'll intuit where to put different pieces of code and how they interact. What is an architectural pattern? Before diving into MVC, let's briefly touch on what an architectural pattern is in software development. Think of it as a tried-and-true solution to a recurring problem in software design. Just as an architect uses blueprints and established patterns to design a stable and functional building, software architects use patterns to structure complex applications. These patterns aren't strict rules, but rather guidelines that promote good design choices, readability, and future maintainability. MVC is one of the most widely adopted architectural patterns for web applications. The problem MVC solves: imagine building a web application without any structure. You'd have a tangled mess of code. Database queries mixed with HTML generation mixed with business logic. This spaghetti code is incredibly hard to understand, debug, and expand. MVC addresses this by separating concerns into 3 distinct, interconnected components. Deconstructing MVC. Let's break down each component. 1. The model, your data and business logic. The model is the brain of your application's data layer. It represents the data your application works with and the rules for interacting with that data. If your application is a blog, a post would be a model. If it's an e-commerce site, product and customer would be models. What the model does represents data. It's the primary interface for interacting with your database. You don't write complex SQL queries directly. Instead, you interact with your models as Ruby objects, and Rails, through a component called Active Record, translates those interactions into database commands. Encapsulates business logic. This is where the rules and logic specific to your application's domain live. For example, a post model might have rules that a post must always have a title. A post's content cannot be empty. The title must be unique. A post belongs to a user. Communicates with the database. Models, via Active Record, handle the processes of saving, retrieving, updating, and deleting data from the database. This is often referred to as CRUD, create, read, update, delete operations. Think of it this way. If you're building a fitness tracker application, your user model knows how to store a user's name and weight, and perhaps has a rule that a user's weight must be a positive number. It doesn't care how that data is displayed or who requested it. It just manages the data and its integrity. 2. The view, your application's presentation layer. The view is the face of your application. It's what the user sees and interacts with in their web browser. Views are responsible for presenting data retrieved from the model in a user-friendly format. In Rails, views are typically HTML files embedded with Ruby code using embedded Ruby or ERB. What the view does, presents data. It takes information passed to it, usually from the controller, and displays it to the user. This might be a list of blog posts, a user's profile page, or a product catalog. User interface, UI. It contains the HTML, CSS, and some JavaScript that define the layout, styling, and basic interactivity of your web pages. Minimal logic. Views should contain very little, if any, complex logic. Their primary job is to display, not to decide or calculate. If a view needs to do something complex, it's usually a sign that the logic belongs in the controller or model. Think of it this way. In our fitness tracker, the view would be the screen that shows the user's current weight, their weight history in a graph, or the form where they can log a new workout. It only deals with how information is presented to the user. 3. The controller, the traffic cop and coordinator. The controller is the brain of your application's request-response cycle. It acts as an intermediary, receiving requests from the user via the view or directly from the browser, interpreting them, delegating tasks to the model, and then selecting the appropriate view to display the results. What the controller does, receives requests. When you type a URL into your browser or click a link, that request first goes to the controller. Interprets requests. It determines what the user wants to do, e.g., show me all blog posts, save this new post, delete that comment. Interacts with the model. Based on the request, the controller instructs the model to perform actions, e.g., fetch all posts, create a new post with this data, delete this specific post. Selects the view. After the model has done its work, the controller decides which view should be rendered to display the outcome to the user. It passes any necessary data from the model to the view. Handles user input. It takes data submitted by the user, e.g., from a form, and passes it to the model for processing and saving. Think of it this way. For our fitness tracker, when you click Save Workout, the controller receives that action. It then tells the workout model to save the new workout data. Once saved, the controller might tell the view to display a workout saved successfully, message, or redirect you to your workout history page. The request-response cycle in Rails, putting MVC together. Let's trace a typical user interaction through the MVC pattern in a Rails application, using our blog example. The user makes a request. You type myblog.com/posts into your browser and press enter, or you click a View All Posts link. Initial thought, the user clicks a link. Refinement for audiobook. Emphasize the URL entry in the browser as the starting point for a clear example. The router intercepts the request. Before the controller even sees it, Rails has a router. The router is like a switchboard operator. It looks at the incoming URL, posts in our example, and maps it to a specific controller and action. For myblog.com/posts, the router knows to send this request to the posts controller's index action. The controller takes over. The posts controller's index action springs to life. Its job is to gather all the data needed to display a list of blog posts. It tells the post model, "Hey, fetch all existing posts from the database." The post model queries the database and returns a list of post objects to the controller. The controller prepares the view. With the list of posts in hand, the controller now decides which view to display. It chooses the index.html view, a convention in Rails where the view name matches the controller action. It then passes the list of post objects to this view. The view renders the page. The index.html view receives the list of posts. It iterates through each post object, formats its title and content, and embeds them into the surrounding HTML structure. It generates a complete HTML document that the browser can understand. The response is sent back. The fully rendered HTML page is sent back to the user's browser. The browser displays the page. Your browser renders the HTML, and you see a beautiful list of blog posts. This entire cycle happens in milliseconds, but understanding each step is crucial. Rails principles. Convention over configuration and dry. Beyond MVC, Rails deeply emphasizes two powerful principles. Convention over configuration, COC. This is perhaps the most famous Rails principle. It means that Rails makes intelligent assumptions about the best way to do things, so you, the developer, don't have to specify every detail. For example, if you have a post model, Rails assumes your database table is named posts. If you have a posts controller with an index action, Rails assumes there's an index.html view file to render. This convention dramatically reduces the amount of configuration code you have to write, letting you focus on your application's unique features. It allows for rapid development, but it also means there's an on-Rails way of doing things that you learn over time. Don't repeat yourself dry. This principle advocates for writing code once and reusing it, rather than duplicating it. Rails promotes dry through various mechanisms like helper methods, partials, and its object-oriented nature, reducing redundancy and making your code base smaller and easier to maintain. These principles combine to create a highly productive development environment where you can build features quickly because much of the boilerplate and setup is handled for you automatically. The magic isn't random. It's carefully designed convention, a historical anecdote, Basecamp and the birth of Rails. You might be wondering where this powerful framework came from. The story of Rails began in 2003 when David Heinemeier Hansson, DHH, was building project management software called Basecamp for his company, 37 Signals, now Basecamp. DHH found the process of web development with existing tools too cumbersome and repetitive. Frustrated, he extracted the common patterns and efficiencies he kept applying across his projects, abstracting them into a new framework. That framework became Ruby on Rails, released to the public in 2004. Rails didn't just provide a set of tools, it popularized a new way of thinking about web development, directly challenging the prevailing enterprise Java and .NET approaches of the time with its speed, simplicity, and focus on developer joy. Companies like Shopify, GitHub, and Airbnb famously started on Rails, demonstrating its scalability and robustness for even complex applications. What's next? You now have a conceptual roadmap for how Rails applications are structured and how they handle requests. We've laid the groundwork for understanding the model, view, and controller components and how they interact within the request-response cycle. We've also touched on the core philosophies of convention over configuration and dry. In the next chapter, we'll start putting these concepts into practice by exploring routing. This is the critical first step in the request-response cycle, where we tell Rails how to map specific URLs to the correct controllers and actions, truly beginning our journey of building our own web application. Chapter 4. Routing. Guiding requests to your application. In the previous chapter, we introduced the Model View Controller, MVC, architectural pattern, and explained how user requests flow through a Rails application. The very first stop for any incoming request is the router. Think of the router as the central switchboard operator for your application. Its primary job is to examine the incoming URL, the web address, and the HTTP method, like GET, POST, etc., and then direct that request to the appropriate controller action. Without a clearly defined route, your application wouldn't know what to do with an incoming web request. Mastering routing is crucial because it defines the publicly accessible entry points to your application's features. Understanding URLs and HTTP methods. Before diving into Rails routes, let's briefly recap how web requests work. When you type a web address into your browser, say https:/products/123, you're making a request. This URL isn't just arbitrary text, it's a structured address. https:// the protocol secure HTTP. Example.com, the domain name, products123. The path which tells the server what resource you're interested in. Along with the URL, your browser also sends an HTTP method. The most common ones are GET, used to retrieve data, e.g., viewing a web page, fetching a list of products. This is the most common method for URLs you type in directly or click links for. POST, used to send data to the server to create a new resource, e.g., submitting a form to create a new user or a new blog post. Patch PUT, used to update an existing resource, e.g., editing a user's profile. Delete, used to remove a resource, e.g., deleting a blog post. These methods are fundamental to REST-ful design, a common architectural style for web services that Rails heavily promotes. REST, representational state transfer, aims to make web applications more organized and predictable by treating everything as a resource, like a user, a post, or a product, and defining standard ways to interact with those resources using HTTP methods. The config/routesRB file, your application's map. All of your application's routes are defined in a single file, config/routesRB. When you created MyFirstApp in the last chapter, Rails automatically generated this file for you. If you open it, you'll see some comments and an empty Rails application routes drawdo, end block. This is where your routing rules will live. Let's start by defining a very simple route. Imagine we want a static About Us page in our MyFirstApp. Basic routes, explicitly mapping paths. The simplest way to define a route is to map an HTTP method and a path to a specific controller action. Suppose we decide that our About Us content will be handled by a page's controller and an action called About. First, let's create our controller. Open your terminal, ensure you are in your MyFirstApp directory, and run. Rails generate controller pages about. This command will create a new file, app/controllers/pagescontroller.rb. Add an empty method action called about inside pages controller. Create a corresponding view file, app/views/pages/about.html.rb. Now open config/routes.rb and add the following inside the Rails application routes draw-do block. Get about to pages #about. Let's break this down. Get, this specifies that we're defining a route that responds to an HTTP GET request. About, this is the URL path. When a user navigates to http localhost:3000/about, this route will be matched. To pages #about, this tells Rails which controller and action should handle the request. Pages corresponds to pages controller. Rails automatically looks for controllers ending with controller.rb. About corresponds to the about method action inside pages controller. Now, if you start your Rails server Rails-S, open your browser, and go to http localhost:3000/about, you should see the content of app/views/pages/about.html.rb. You can edit this file to add actual content like h1 about us, h1p we are building an amazing app/p. The root, your application's homepage. Every web application needs a homepage. In Rails, this is defined by the root. By default, your Rails application shows a welcome page. Let's change that to point to our pages controller's home action. First, let's add home to our pages controller. You can either run Rails generate controller pages home, and it will add home to the existing pages controller.rb, or manually add the home action inside app/controllers/pagescontroller.rb. App/controllers/pagescontroller.rb. Class pages controller, application controller. Def about, and def home, and then create app/views/pages/home HTML.rb and add some content like h1 welcome to my first app/h1. Finally, in config/routes.rb, add this line, root pages #home. This tells Rails that requests to the application's root URL, e.g., http localhost:3000/ should be handled by the home action of the pages controller. Resourceful routes, the power of resources. While defining individual get, post, patch, and delete routes is useful for specific cases, it can quickly become repetitive for common web application resources like blog posts, users, or products. Most web applications follow the res-tful pattern for interacting with these resources, meaning they typically need actions for listing all resources, index, showing a single resource, show, creating a new resource, new form, create submission, editing an existing resource, edit form, update submission, deleting a resource, destroy. Imagine defining 7 separate routes for each resource. Rails provides a powerful helper to simplify this. Resources. Let's say we want to build a simple blog. Our main resource will be posts. In config/routes.rb, remove the get, about, and root for a moment if you added them, or just comment them out with a hash in front of the line and add. Resources post. This single line tells Rails to automatically generate 7 common res-tful routes for a post resource. You don't see them directly in routes.rb, but Rails knows how to create them. The routes generated by resources, posts. To see exactly what routes resources, posts generates, you can run a command in your terminal, Rails routes. You'll get a detailed list. For posts, it will look something like this. Prefix, verb, URI pattern, controller, hash action, purpose. Posts get/posts. Format, post hash index, list all posts. Posts/posts. Format, post hash create a new post. New post, get post/new. Format, posts hash new form to create a new post. Edit post, get posts, id/edit. Format, posts hash edit form to edit an existing post. Post get/post/id. Format, post hash show display a specific post. Patch/post/id. Format, post hash update an existing post, partial update. Put/post/id. Format, post hash update an existing post, full replacement. Delete/post/id. Format, post hash destroy delete a specific post. Notice the format part. This allows for optional format extensions like JSON or XML, useful for building APIs. Key observations: HTTP verb matters. The same URI pattern, e.g., posts, can map to different actions, index vs. Create depending on the HTTP method, get versus post. This is fundamental to REST. id parameter, roots like posts /id have a placeholder id. This means that whatever value is in that part of the URL, e.g., 5 in posts 5, will be passed as a parameter named id to the controller action, allowing you to fetch a specific post. Path helpers. The prefix column gives you convenient method names like postpath, new postpath, postpath, ID. These are called path helpers or URL helpers. You use them in your Rails code, especially in views, to generate URLs without hard-coding them. For example, instead of writing a href equals /posts, you'd write %=linkto all posts, postpath%. This makes your links robust. If you ever change the actual URL pattern for posts, your path helper will automatically update the generated URL wherever it's used. This is a phenomenal amount of work for a single line of code. It adheres to the convention over configuration principle beautifully. Customizing resources. Sometimes you don't need all 7 actions for a resource. You can opt to include or exclude specific actions. Resources, users only. Index, show, hash only create roots for listing and showing users. Resources, comments except. New, edit, hash create all roots except new and edit. You can also nest resources to show relationships, e.g., comments belonging to a post. Resources, posts do. Resources, comments hash this means posts, posted/comments. And this creates roots for comments that include the posted in the URL, making it clear that the comments belong to a specific post. What's next? You now understand how fundamental routing is in a Rails application. You know how to define explicit roots for specific paths, and more powerfully, how to use resources to automatically generate a full set of res-tful roots for your application's data models. You've also seen how to inspect your roots using Rails roots and learned about the convenient path helpers. The router's job is to send requests to the correct controller action. In the next chapter, we'll continue our deep dive into the MVC pattern by focusing on the model. We'll learn how Active Record, Rails' powerful object relational mapper, allows your application to interact seamlessly with its database, making the persistence of your application's data incredibly intuitive. Chapter 5, Active Record, Interacting with your database models. In the previous chapter, we saw how the Rails router directs incoming requests to the appropriate controller. Now we turn our attention to one of the most powerful and defining features of Ruby on Rails, Active Record. Active Record is the M in MVC, the model layer, and it's how your Rails application interacts with its database. At its core, Active Record is an object relational mapper, ORM. This might sound like jargon, but it's a brilliant solution to a common problem in web development. What is an ORM? The bridge between objects and tables. Traditional databases, like the ones Rails works with, store data in tables using rows and columns. Programming languages, however, typically work with objects. For example, in Ruby, you might have a post object with title and content attributes. To save this post object to a database, you would historically have to write specific SQL queries like insert into posts, title, content values, my title, my content. To retrieve it, you'd write select from posts where id equals 1, and then manually convert the resulting row back into a programming language object. This process, known as impedance mismatch, is cumbersome and error-prone. An ORM acts as a bridge. It allows you to interact with your database using the familiar paradigm of your programming language's objects, rather than raw SQL. Active Record maps rows in your database tables to Ruby objects and columns in those tables to object attributes. So, instead of writing SQL like, select from posts where published equals true, you write Ruby code that interacts with your post model, which uses Active Record, post where published, true. This makes your code more readable, more maintainable, and less prone to SQL injection vulnerabilities, a common security risk. It also keeps your application portable. If you decide to switch from SQLite to PostgreSQL, much of your model code remains the same, as Active Record handles the differences in SQL dialects for you. Active Record as Rails ORM. Active Record is a fundamental component of Rails. It provides a rich set of conventions and methods that make database interactions intuitive and efficient. Conventions. Bridging the gap automatically. Active Record's power comes partly from its strong adherence to convention over configuration. It makes elegant assumptions, saving you from writing endless configuration files. Model naming. If you have a Ruby class named Post, Active Record assumes it corresponds to a database table named Posts. Note the singular class name, plural table name. Table naming. Active Record expects primary key columns to be named id column to attribute mapping. A column named name in your user's table will automatically become an attribute name on your user objects. Timestamps. If your table has created at and update at columns, which Rails automatically adds, Active Record will manage these timestamps for you. These conventions mean less code for you to write and a more consistent application structure. Creating your first model with Active Record. Let's create a post model for our blog application. This model will represent the post's users right. Each post will have a title and content. To create a model, we use the Rails generator. Rails generate model post title, string content, text. This command does two significant things. Creates the model file. It generates app/models/postrb. If you open this file, you'll see #app/models/postrb. Class post application record. And the key here is class post application record. This means our post class inherits a ton of functionality from Active Record via application record, giving us all the ORM capabilities out of the box. Creates a database migration. It also generates a migration file in db/migrate/. This file is named with a timestamp and then create a posts.rb. We'll dive deeper into migrations in the next chapter, but for now, understand that it's a set of instructions to create the corresponding posts table in your database. The migration file will look something like this. #db/migrate/yimtums create a posts.rb. Class create posts Active Record. Migration 7.0, the 7.0, indicates the Rails version. Def chain. Creatable posts duty. T-string title. T-text content. T-timestamps. And. This migration defines that the posts table will have a title column of type string for short text and a content column of type text for longer text. The T-timestamps line is a powerful Active Record convention. It automatically adds created at and update at columns, which Rails will maintain for you, tracking when a record was created and when it was last updated. Migrating your database. To apply the changes defined in the migration file, i.e., create the posts table in your database, you need to run the migration. Rails db migrate. You'll see output indicating that the create a posts migration was run. This command inspects your db/migrate folder, finds any migrations that haven't been applied, and executes their instructions to update your database schema. If you're using SQLite, the default, this will modify your db/development SQLite 3 file, performing CRUD operations with Active Record. Now that we have a post model and a posts table, let's play with it. A great way to interact with your models directly is through the Rails console. The Rails console, or Rails-C. The Rails console is a fantastic tool that allows you to interact with your application's models and other components directly from the command line. It's perfect for testing ideas, debugging, or performing quick data operations. Open your terminal, navigate to your MyFirstApp directory, and type Rails console. You'll see a prompt, often starting with main 0010. This is just like the we used in Chapter 1, but it has your entire Rails application loaded, meaning you can directly access your models. Create C from CRUD. Let's create a new post. In the Rails console, post 1 equals post create title. My first blog post, content. This is the content of my first post. When you press enter, Active Record sends an insert statement to your database. You'll see output in the console confirming the creation, including the assigned id, created at, and update at timestamps. You can also create a new post object and then save it. In the Rails console, post 2 equals post new creates a new object in memory. not yet in the database. Post 2 title equals, another great post. Post 2 dot content equals, more exciting content here. Post 2 save hash saves the object to the database. The save method returns true if successful, false otherwise, e.g., if validations fail, which we'll cover later. 2 read R from CRUD. Active Record provides many ways to retrieve data. Find by ID, post find post 1. ID, hash finds the post with the given ID. If no post is found with that ID, it will raise an error. Find by ID or return nil, post find B title, my first blog post. Hash finds the first post with this title. This returns nil if no record matches, which is useful when you prefer to handle the not found case gracefully. Find all, post all hash returns all posts in the database as an active record relation, a collection of objects. Filter where, post where title, my first blog post. Hash returns an active record relation of all posts with this title. Post where, created at, 1 day ago, hash posts created in the last 24 hours. The where method is powerful. It builds a query but doesn't hit the database until you actually need the results, e.g., by iterating over them or calling first, last, count all. This is called lazy loading and is a performance optimization. Order. Post order created at. Desk hash orders posts by creation date, newest first. Combine queries. You can chain where, order, and other query methods to build complex queries. Post where published, true, order created at. Desk, limit 5, hash the 5 most recent published posts. 3 update, U from CRUD. To modify an existing post, post equals post find B title, my first blog post. Post.content equals, this post has updated content. Post save hash saves the changes to the database. Or you can update attributes and save in one go. Post update title, updated first blog post title. The update method directly applies the changes and saves them. For delete, D from CRUD. To remove a post from the database, post equals post find B, title. Updated first blog post title. Post.destroy hash permanently deletes the record from the database. Confirm it's gone. Post all hash see if the post is still there. You can also delete multiple records. Post.destroy all deletes all posts. Or post.delete by. To exit the Rails console, type exit and press enter. What's next? You've learned that Active Record is Rails' powerful object relational mapper, enabling you to interact with your database using Ruby objects rather than raw SQL. You've created your first model, understood the role of migrations, and performed the fundamental CRUD operations directly in the Rails console. In the next chapter, we'll dive deeper into migrations. While we briefly touched on them here, we'll explore exactly how they work, how they version control your database schema, and how you can modify your database structure over time without losing data or causing conflicts. This is crucial for collaborative development and iterating on your application. Chapter 6, Migrations, Evolving Your Database Schema. In the last chapter, you encountered database migrations when we generated our post model. We ran Rails DB, migrate to create the posts table. Now, it's time to fully understand what migrations are and why they are an essential part of developing a Rails application. Why migrations? The challenge of database changes. During the lifetime of any software project, the structure of its database almost always changes. You might need to add a new column to an existing table, e.g., author to posts. Rename a column. Change a column's data type. Create new tables to store new types of data. Remove tables or columns that are no longer needed. If you were working alone on a small project, you might simply open a database management tool and manually alter the tables. However, this approach quickly becomes problematic. Version control. How do you track these changes? How do you know what changed when and why? How do you revert to a previous state if something goes wrong? Collaboration. If multiple developers are working on the same project, how do they ensure everyone's database schema is up to date and consistent? Manually applying changes can lead to conflicts, and it works on my machine syndrome. Deployment. How do you reliably apply these changes to your production server without impacting live data? Database migrations solve these problems. They provide a structured, version-controlled way to manage changes to your database schema. Each migration is a separate file that contains instructions for modifying the database. Rails keeps track of which migrations have been run, ensuring consistency across different environments and developers. Anatomy of a migration. When you ran Rails generate model post title, string content to text, Rails created a migration file for you in the db/migrate directory. The naming convention is crucial. Yimtams create a post sarbi. The long number at the beginning is a timestamp, year, month, day, hour, minute, second, which uniquely identifies the migration and ensures that migrations are applied in the correct order. Let's look at the content of a typical migration file. db/migrate/20,230 1,026,123,456 create a post sarbi. Class create posts active record. Migration 7.0 hash the Rails version ensures compatibility. Def chain creatable posts duty. T-string title, T-text content, T-timestamps hash adds created at and update at columns. End, create posts, the class name of the migration. It's often auto-generated based on the command you use, e.g., create posts for create posts. Active record, migration 7.0, all migrations inherit from active record, migration. The 7.0 specifies the version of Rails for which the migration was generated, ensuring compatibility with its internal APIs. Def change, this is the most common method in a migration. It's designed to be reversible. Rails can infer how to undo the migration if you need to roll back, more on that shortly. For instance, creatable knows how to dropable. If a change isn't reversible, you would use def up and def down methods instead, where up applies the change and down explicitly reverses it. Creatable posts duty. This instruction tells Rails to create a new table named posts. The T block allows you to define the columns for this table. T-string, title, adds a column named title with a string data type, suitable for short text, roughly up to 255 characters. T-text content adds a column named content with a text data type, suitable for longer text paragraphs. T-timestamps, this is a shorthand for adding two columns, created at and update at. These are automatically managed by Rails, recording when a record was first created and when it was last modified. This is immensely useful for auditing and data management. Common migration methods. Rails provides a set of helper methods within migrations to perform various schema changes. Creatable creates a new table as seen above. Dropable deletes a table. Add column adds a new column to an existing table. Add column posts author string hash adds author as a string to posts table. Remove a column deletes a column from a table. Remove a column posts author hash removes author from posts table. Rename column renames an existing column. Rename column posts author creator hash renames author column to creator in posts table. Change column changes the data type or properties of an existing column. Change column posts title text hash changes title to a text field. Add index adds a database index to a column, which can significantly speed up queries on that column, especially for foreign keys or frequently searched columns. Add index posts authored hash adds an index on the authored column in posts table. Generating new migrations. You can generate a new migration file using the Rails generate migration command. It's a good practice to give your migration a descriptive name that reflects its purpose. Let's add an author column to our posts table, which is a string for simplicity at this stage. Later it could be an association to a user model. See Chapter 9. Rails generate migration add author to posts author, string. This will create a new migration file like yimtams sat author to posts sarbi. Its content will automatically be db/migrate/yimtams sat author to posts sarbi. Class add author to posts active record, migration 7.0. Def chain, add column posts author string. End. Notice how Rails intelligently figures out the add column method based on add author to posts and author, string. This is another example of convention over configuration in action. Running migrations, Rails db, migrate. To apply any pending migrations, i.e., new migration files that haven't been run against your database yet, you use the following command. Rails db, migrate. Rails checks a special table in your database, schema migrations, to see which migrations have already been applied. It then runs any outstanding migrations in chronological order, based on their timestamps. After running the Add Author to Posts migration, your posts table in the database will now have an author column. Rolling back migrations, undoing changes. Sometimes you'll make a mistake in a migration, or you just want to undo the very last database change you applied. Rails provides DB rollback for this. Rails DB rollback. This command undoes the very last migration that was applied. If your migration used the change method, as most auto-generated Rails migrations do, Rails knows how to reverse the action, e.g., add column reverses to remove a column. You can also specify how many migrations to roll back. Rails DB rollback step equals 2 hash rolls back the last 2 migrations. Be cautious with rollback in production environments, as undoing schema changes might lead to data loss if not handled carefully. The schema RB file, your database blueprint. After running Rails DB migrate, you'll notice that the db/schema RB file in your project is updated. This file is a snapshot of your database's current schema. It's essentially a blueprint representing the state of your database after all migrations have been applied. Important points about schema RB: do not edit this file manually. It is generated automatically whenever you run Rails DB migrate. Check it into version control. This file is crucial for new developers joining a project. Instead of running every single past migration, they can simply run Rails DB schema load to load the current schema directly, which can be much faster for large projects with many migrations. This command effectively bypasses all individual migrations and directly applies the schema defined in schema RB. It's a simplified, database-agnostic representation of your schema when to use migrations versus schema RB. Migrations are for evolving your database schema over time. They record the changes, add column, create table. Schema RB is for representing the current state of your schema. It's the result of all those changes. When a new developer starts on a project, they clone the repository, run bundle install, and then can either Rails DB migrate. This will run all historical migrations, recreating the database step by step. Rails DB schema load. This will load the db/schema RB file directly, creating the database in its current state in one go. This is often faster for large projects. What's next? You now have a solid understanding of active record migrations. You know how they provide a version-controlled way to manage your database schema, how to generate new migrations, how to apply them with Rails DB migrate, and how to undo recent changes with Rails DB rollback. You also understand the role of db/schema RB as the snapshot of your current database structure. With your database set up and ready, it's time to connect it to the web. In the next chapter, we'll dive into controllers asterisk. We'll learn how controllers receive requests, interact with our models, like our post model, process data, and prepare responses, acting as the crucial intermediary in the Rails MVC pattern. Chapter 7, Controllers, the brains of your application. We've covered the model as active record and established how your database schema is managed with migrations. We've also defined how requests find their way through the router. Now it's time to complete the MVC picture by focusing on the controller. As we discussed in Chapter 3, the controller is the traffic cop, or brains of your application. It receives requests from the router, orchestrates interactions with the model, processes any necessary data, and then decides which view to render to the user. Controllers bridge the gap between incoming HTTP requests and the internal logic of your application, creating a controller. Just like with models, Rails provides a generator for controllers. We briefly saw this in our routing chapter when we made the pages controller. Let's create a posts controller to manage our blog posts. First, ensure you are in your application's root directory in the terminal. Then run Rails generate controller posts. This command will create app/controllers/posts controller RB. Also create a directory app views posts where your post-related views will live. If you open app/controllers/posts controller RB, you'll see a basic class definition. App/controllers/posts controller RB. Class posts controller, application controller. And all your application's controllers inherit from application controller, which itself inherits from action controller, base. This inheritance provides them with a wealth of functionality, including access to request and response objects, session management, and various helper methods that simplify common tasks. Controller actions. The methods that respond. The methods defined within a controller are called actions. Each action typically corresponds to a specific user interaction or URL path. Following Rails res default conventions, controllers often have actions like index, show, new, create, edit, update, and destroy. Let's implement the index and show actions for our posts controller. app/controllers/posts controller RB. Class posts controller, application controller. Def index, #fetch all posts from the database. At posts equals post all. And def show, #find a specific post by its ID. At post equals post find params, ID. And what's happening here? Def index. This action will be responsible for displaying a list of all blog posts. Inside this action, we use the postall active record method from Chapter 5 to retrieve all records from the posts table. At posts equals postall, notice the @ symbol before posts. This signifies an instance variable. In Rails, any instance variables defined in a controller action are automatically made available to the corresponding view. So, index.html will be able to access the @posts variable to display each one. Def show, this action will display the details of a single post. At post equals post find, params, ID, this line is crucial. When a request comes in for a specific post, e.g., Articles 5, the Rails router parses the URL and extracts the 5 as a parameter. Named id, these parameters are available in the controller via the params hash. So, params, ID, will contain the ID of the post we want to find. We then use post find active record to fetch that specific post from the database and assign it to the instance variable at post, making it available to the show view. Remember, the router from Chapter 4 must know how to map URLs to these actions. If you've been following along, your config/routesRB file should already have resources, posts, which automatically creates the necessary routes for index and show, among others. Rendering views. After a controller action has interacted with the model and prepared any necessary data, it needs to render a view to send back an HTML response to the browser. By convention, Rails automatically renders a view with the same name as the action, located in a subdirectory matching the controller's pluralized name. The index action in posts controller will implicitly render apps/views/posts/index.html. The show action in posts controller will implicitly render apps/views/posts/show.html. You will need to create these view files in the app views posts directory. app/views/posts/index.html. h1 all blog posts h1. %at posts, each do post %. Div h2 % equals post title %h. p % equals post.content %p. % equals linked view post path post %. Div hr %end %. Here, h1 all blog posts h1 is standard HTML. %at posts, each do post %. %end % is ERB, embedded Ruby. This is a Ruby each loop from Chapter 1 that iterates over the @posts instance variable, the array of post objects we got from postall in the controller. For each post object in the array, it executes the code inside the loop. Notice %% means execute Ruby code, but don't print its output. h2 % equals post title %h2, and p % equals post.content %p. Here, % equals % means execute Ruby code and print its output. So, it prints the title and content attributes of each post object. % equals linkto, view post, post path post %. Linkto is a Rails view helper that generates an HTML tag. Post path, post, is a path helper from Chapter 4 that generates the URL for a specific post, e.g., posts1. app/views/posts/show.html. h1 % equals at post title %h. p % equals at post.content %p. p % equals linkto edit post path at post %. % equals linkto back to posts path %. p This view displays the title and content of the singlet post, object passed from the show action. It also uses path helpers to create links back to the list of all posts and to an edit page, which we'll build next. Now, if you start your Rails S server, create a few posts in the Rails console, and then navigate to http localhost:3000/posts, you should see your list of posts. Clicking View Post will take you to the individual post page, handling user input: new, create, edit, update, destroy. Beyond just displaying data, controllers are responsible for handling user input, such as submitting forms to create or update data. Let's add the actions for creating and updating posts: new and create actions. The new action typically just prepares an empty object that the form can use to gather input. The create action receives the form submission and attempts to save the new record to the database. app/controllers/postscontroller_rb, add these actions. Class posts controller, application controller. Hash, index and show actions remain, def new. At post equals post new hash, create an empty post, object for the form. And def create. At post new, post params, hash create new post with data from the form. If at post save, redirecto at post notice. Post was successfully created. Hash redirect to the show page for the new post. Else, render new status. Unprocessable entity hash re-render the new form if validation fails. And private hash methods below this are not accessible as actions. Def post params require post, permit, title, content, hash strong parameters. And then create app/views/posts/new HTML h1 new post h1. % = form with model. At post do form %. Div % = form label, title %br. % = form text field, title %. Div % = form label, content %br. % = form text area, content %. Div % = form submit, create post, %. Div %end %. % = linked back to posts, posts path %. Strong parameters, a critical security feature. Notice post params in the create action. This is the strong parameters feature, a crucial security mechanism in Rails. When a user submits a form, the data comes into your controller in the params hash. Without strong parameters, an attacker could potentially inject malicious data into your database by sending extra, unexpected fields through the form. For example, if your user model had an isadmin column, an attacker might try to send isadmin true in their form submission. Strong parameters requires you to explicitly permit which fields are allowed to be passed into your model for mass assignment. Params require post ensures that the params hash must contain a top-level key named post, e.g., post equals, title equals, content equals. If it's not there, Rails raises an error. Permit, title, content, specifies that only title and content are allowed within the post hash. Any other keys are filtered out. This protects your application from unintended data changes. Edit and update actions. Similar to new and create, edit prepares an existing object for modification, and update processes the form submission. app/controllers/postscontroller_rb, add these actions. Class posts controller, application controller. Hash, index show new, create actions remain. Hash add this private helper method to find posts by ID, ensuring it's available for show, edit, and destroy. Before action, set post only. %I, show edit update destroy. Def edit, hash at post is already set by before action, set post. And def update, hash at post is already set by before action, set post. If at post update, post params, hash update post with data from the form. Redirecto at post notice. Post was successfully updated. Else, render edit status, unprocessable entity. And hash private section with post params, private. Hash use callbacks to share common setup or constraints between actions. Def set post. At post equals post find params, ID. And def post params. Params require post, permit, title, content. And then create app/views/posts/edit HTML h1 edit post h1. % = form with model. At post do form %. Div % = form label, title %br, percent equals form text field, title %, div, percent equals form label, content %br, percent equals form text area, content %, div, percent equals form submit update post, div, %end percent equals linkto, show post, at post percent equals linkto back to posts, posts path %, destroy action. The destroy action simply deletes a record. app/controllers/posts controller RB, add this action. Class posts controller, application controller, hash all previous actions and methods, def destroy. At post.destroy, hash delete the post from the database. Redirecto posts URL notice, post was successfully destroyed. Status, see other. End, hash private section remains, end. A note on status, see other in redirecto. This is important for SEO and correct HTTP responses for delete actions. It indicates that the client should see and get the redirected content rather than attempting to repost to the new location. Callbacks. Before action. In our posts controller, you might have noticed a repetitive line in show, edit, update, and destroy. Find the post by ID. Rails provides callbacks to avoid this repetition. Before action is a common callback that runs a specified method before the specified actions. By adding before action, set post only, %i, show, edit, update, destroy, and defining set post in the private section, any of those actions will automatically have it post populated before their main logic executes. This keeps your actions lean and focused. What's next? You've learned that controllers are the crucial coordinators in your Rails application, handling requests, interacting with models, and rendering views. You've implemented the full suite of res-tfal actions, index, show, new, create, edit, update, destroy for your post resource, including building forms and understanding the importance of strong parameters. We've focused heavily on controllers and views in this chapter. In the next chapter, we'll return to our models to explore crucial features like validations, ensuring data quality, and associations, defining relationships between different models, like a post belonging to a user. This will make our application more robust and allow us to build more complex and interconnected features. Chapter 8, Views, bringing your application to life. In the journey of building your Rails application, we've covered the model, active record, and migrations, and the controller, handling requests and coordinating logic. Now, it's time to focus on the view, which is the part of your application that users directly interact with. The view is what transforms the data and logic from your models and controllers into compelling, user-friendly web pages. ERB, embedded Ruby. Rails views are typically written using ERB, embedded Ruby. ERB files combine standard HTML with Ruby code, allowing you to dynamically generate content based on the data provided by your controllers. There are two primary ways to embed Ruby code in an ERB file, %%. Execute Ruby code, don't print output. This tag is used for control flow statements, like if conditions, each loops, variable assignments, or calling methods that don't directly produce HTML output. % if it posts any, %p there are posts to show, /p, %end The Ruby code within % is executed, but nothing is inserted into the HTML output at that point. %=%. Execute Ruby code, print output. This tag is used when you want the result of a Ruby expression to be inserted directly into the HTML. H1% equals at post title %h. P current time. % time now %p. The Ruby code inside % equals. % is evaluated, and its return value, converted to a string, is placed into the HTML document. In the previous chapter, we already saw ERB in action when creating index.html and show.html for our posts controller. Let's revisit some key aspects that make views powerful and flexible. Layouts. Consistent structure across your application. Imagine every page in your application needs the same header, footer, navigation bar, and basic HTML structure. Doc type, HTML, head, body tags. Copying and pasting this markup into every single view file would be a violation of the dry, don't repeat yourself, principle and a maintenance nightmare. Rails solves this with layouts. A layout file acts as a template for your application's pages. It contains the common HTML structure, and then a special placeholder tells Rails where to insert the content of the specific view being rendered. By default, every Rails application comes with app/views/layouts/application HTML. If you open it, you'll see something like this: doctyp HTML. HTML. Head. Title my first app title. %CSRF meta tags %. % equals CSP meta tag %. % equals stylesheet link tag, application, data turbo track. Reload %. % equals JavaScript import map tags %. Head. Body. P class equals notice, % equals notice %P. P class equals alert % equals alert %P. % equals yield %. Body. HTML. HTML structure. This file contains the standard doctyp HTML, HTML, head and body tags. % equals yield %. This is the magic. When a controller action renders a view, e.g., posts/index.html, the content of that specific view file is inserted directly at the position of the yield keyword in the layout. %CSRF meta tags %, % equals CSP meta tag %. These are security-related tags that Rails automatically includes to protect against common web vulnerabilities like cross-site request forgery, CSRF, and content security policy, CSP. You generally don't need to touch them. % equals stylesheet link tag, application, data turbo track, reload %. This loads your application's CSS files, making them available to all pages using this layout. % equals JavaScript import map tags %. This loads your application's JavaScript files, managed by Rails import maps. Flash messages, notice alert. The lines P class equals notice, % equals notice %P, and P class equals alert % equals alert %P are for displaying flash messages. These are temporary messages, like post was successfully created. From Chapter 7, that Rails passes between redirects. If the notice or alert variable contains a message, it will be displayed. Otherwise, nothing is rendered. You can modify this application HTML layout to include a header, footer, or navigation bar that appears on every page of your application. Partials, reusable view snippets. While layouts handle the overall page structure, you often have smaller, reusable chunks of HTML within your views. For example, presenting a post object in a list on the index page might involve displaying its title, content, and a link. If you also wanted to display a post summary on a user's profile page, you'd be duplicating that HTML. Partials solve this. A partial is a view file, often with a leading underscore in its file name, e.g., post.html, that contains a segment of HTML that can be rendered within other views or layouts. Let's refactor our app/views/posts/index.html using a partial. Create the partial file. In the same directory app/views/posts, create a new file named post.html. Move reusable code. Cut the rendering logic for a single post from index.html and paste it into post.html. %#app/views/posts/post.html%. Div h2 % equals post title %h. P % equals post.content %p. % equals linked view post, post path post %. Div hr. Notice, we refer to post directly here, not at post. This is because partials receive local variables which will pass to them. Update index.html to render the partial. Modify app/views/posts/index.html to use the partial. %#app/views/posts/index.html%. h1 all blog posts h1. % if it posts any. %. % at posts, each do post %. % equals render partial, posts post locals, post post %. %end %. %else %. P no posts yet. Create 1/p. %end %. Alternatively, Rails has a powerful convention when rendering collections. %#app/views/posts/index.html cleaner version %. h1 all blog posts h1. % equals render at posts %. This single line replaces the entire loop. %. % unless it posts any. %. P no posts yet. Create 1/p. %end %. When you pass a collection of active record objects, like it posts, to render, Rails automatically iterates over the collection and renders the corresponding partial for each object. It knows to look for post.html and passes each post object as a local variable named post to the partial. This is an excellent example of convention over configuration, saving you many lines of code. Partials promote the dry principle and make your views cleaner and easier to manage. Helpers, simplifying view logic. While views should primarily focus on presentation, there are often small pieces of logic or formatting tasks that are specific to rendering information. You don't want to clutter your views with complex Ruby code, nor do you want to duplicate common operations. This is where view helpers come in. Rails provides many built-in helpers, like linkto, formWidth, number tockerency. You can also create your own custom helpers in app/helpers/application-helper-rb or in controller-specific helper files, e.g., app/helpers/post-helper-rb. For example, if you frequently need to format a date, you could create a helper, app/helpers/application-helper-rb. Module application helper. Def formatted date. Date strf time, %b, %d, %y, if date present. And, then in your view, p published on, % formatted date at post created at, %p. Helpers keep your views clean and encapsulate reusable presentation logic. Form helpers. Building robust interactions. We used formWidth in the previous chapter to create forms for posts. Let's delve a little deeper. % formWidth model. At post do form %. % if form object errors, any. % div id equals error explanation. h2 % equals pluralize. Form.object.errors.count. Error, % prohibited this post from being saved, /h2. Ul, % form object errors full messages, each do message %. Lie % equals message %ly. %end %. Ul, div, %end %. Div, % equals form label, title %br. % equals form text field, title %. % if form object errors title, any. % span class equals error message % equals form object errors, title join. % span. %end %. Div, %hash, other fields. %end %. FormWidth is a powerful helper that dynamically generates the correct HTML form based on the active record object. At post, you pass to it. If at post is a new record, not yet saved, FormWidth will generate a form that posts to create a new post. If at post is an existing record, FormWidth will generate a form that patches or puts to /posts/id to update the existing post. This magic is why you don't need separate code for new and edit forms. The doForm block yields a form object, an instance of action view, helpers, form builder, which provides methods for creating form elements like text field, text area, submit, label, etc. It handles naming conventions for form fields so your controller can easily access them via params. Error display, the if form object errors, any, block demonstrates how to display validation errors. Form object refers back to the at post object, and errors is an active model, part of Rails that handles validations, collection of validation failures. We'll explore validations more in the next chapter. The asset pipeline, briefly. While not strictly part of the view itself, the asset pipeline plays a crucial role in how your views are styled and made interactive. It's a framework that concatenates and minifies JavaScript and CSS assets, transforming them into a format that can be served quickly by a web server. app/assets/stylesheets/application CSS. This file often serves as an entry point for your CSS. You can import other CSS files here at import posts, or write your styles directly. app/assets/javascripts/application.js for older Rails setup before import maps. This would typically be a manifest file for JavaScript. However, modern Rails 7+ has largely moved towards import maps for JavaScript, simplifying things. You'll mainly put your JavaScript in app/javascript/controllers/ for stimulus, which we'll discuss later, or individual files. Images. Static images are placed in app assets images. The asset pipeline significantly helps with performance by preparing your assets for efficient delivery to the browser, especially in production. What's next? You've now explored the view layer of your Rails application in detail. You understand how ERB allows you to combine HTML and Ruby to dynamically generate content, how layouts provide a consistent structure, and how partials promote code reuse. You also gained a deeper understanding of form helpers and the basics of the asset pipeline. With the view layer now familiar, we'll return to our models in the next chapter to add crucial features. Validations, ensuring your data is clean and correct before it hits the database, and associations, defining relationships between your different models, which is how applications manage complex real-world data like a user having many posts. These are the final pieces of the core MVC pattern we need to master before building more complex features. Chapter 9: Forms, Validations, and Associations. Building robust interactions. We've covered how to display and present data through views, and how controllers handle the actions of creating and updating records. But what if a user submits a post without a title, or enters a negative number for an age? This is where validations come in, ensuring that incoming data meets your application's requirements before being saved to the database. Furthermore, real-world applications don't just deal with isolated pieces of data. Users write posts, posts have comments, products belong to categories. Associations define these relationships between your different models, allowing your application to represent complex real-world data structures and manage connected information seamlessly. Server-side validations, ensuring data quality. Validations are rules that ensure the data stored in your database is clean, consistent, and meaningful. In Rails, validations are typically defined in your models. This is crucial because it ensures data integrity irrespective of how the data is created, e.g., through a web form, an API, or the Rails console. Let's revisit our post model and add some validations. We want to ensure that every post has both a title and content. app/models/post_rb. Class post application record. Validates title presence, true length, minimum 5. Validates content presence, true, and let's break down these validation methods. Validates title presence, true. This rule dictates that the title attribute must not be blank or nil. If a post is saved without a title, this validation will fail. Length, minimum 5. This is an additional validation on the title that requires it to be at least 5 characters long. Validates content presence, true. Similarly, this requires the content attribute to be present. How validations work. When you try to save an active record object, using save, create, update, etc., Rails automatically runs all defined validations. Save and create. These methods return true if validations pass and the record is saved, or false if validations fail. If they return false, the record is not saved to the database. Save and create. These methods are similar, but will raise an active record. Record invalid exception if validations fail. This is typically used when you expect validations to pass and want the application to crash if they don't, e.g., in development or specific background jobs. Valid, this method explicitly runs validations and returns true or false without attempting to save the record to the database. Invalid, the opposite of valid. Accessing validation errors. When a validation fails, the error messages are stored in the errors object associated with the model instance. You can inspect these errors in the Rails console. In the Rails console, post equals post new content, this is some content, hash missing title. Post valid equals false. Post errors full messages, equals title can't be blank. Title is too short, minimum is 5 characters. In Chapter 8, we showed how to display these errors on the form using form object errors. This provides helpful feedback to the user when their input doesn't meet the requirements. Always ensure you are displaying these errors to the user so they can correct their input. Common validation helpers. Rails offers a rich set of built-in validation helpers. Presence ensures a field is not empty. Length checks string length, e.g., minimum, maximum in is. Uniqueness ensures a field's value is unique across all records in the table, e.g., validates email uniqueness, true. Numericality ensures a field is a number, e.g., greater than, less than, or equal to. Format ensures a field matches a regular expression pattern, e.g., for email formats. Inclusion-exclusion checks if a field's value is within outside a given set of values. Confirmation, useful for password confirmation fields. Validations are your first line of defense for data integrity, making sure your application only stores correct and meaningful information. Model associations, connecting your data. Most real-world applications involve data that is related. For instance, a blog post is typically written by a user, and that post can have many comments. Associations in Rails allow you to define these relationships between your active record models, making it easy to navigate and manipulate related data. Rails supports several types of associations, with the most common being belongs to, denotes a one-to-one or one-to-many relationship where the current model is on the many side of the relationship. It holds the foreign key. Has many denotes a one-to-many relationship where the current model is on the one side of the relationship. Has-on denotes a one-to-one relationship. Has many through denotes a many-to-many relationship through another model. Let's build a typical blog setup. A user can write many posts, and a post belongs to a user. Step 1. Create the user model. First, generate a user model with name and email attributes. Rails generate model username, string email string. Run the migration to create the user's table. Rails DB migrate. Don't worry about passwords or authentication yet, we'll cover that in Chapter 10. Step 2. Add associations to models. Now, we define the relationships in our models. app/models/user_rb. Class user, application record. Has many, post hash a user has many posts. And app/models/post_rb. Class post, application record. Validates title presence, true length. Minimum 5. Validates content presence, true. Belongs to, user hash a post belongs to user. And step 3. Add the foreign key to the posts table. For a belongs to association, the model that belongs to another needs to have a foreign key column that stores the ID of the associated record. Our posts table needs a userid column. Generate a migration to add userid to posts. Rails generate migration add userref to posts user references. The user references part is a Rails shortcut. It automatically generates a userid column of the correct type, an integer, and also creates an index on that column, which is good for database performance. The generated migration will look something like this. db/migrate/yimdhum sagiserif Class add userref to posts active record migration 7.0. Def chain addreference posts user null false foreign key true. And the null false option means a post must be associated with a user, implying that if you try to create a post without a userid, a validation error will occur. Foreign key true adds a database-level constraint for referential integrity. Run the migration, Rails DB migrate. Step 4. Using associations in the Rails console. Now, the magic of active record associations comes to life in the console. In the Rails console, user equals user create name. Alice email, alice@example.com. Hash user id, one name. Alice email, alice@example.com created at, update det. Create a post associated with Alice. Post equals user posts create title. Alice's first post, content, hello from Alice. Hash equals hash post id, one title. Alice's first post, content, hello from Alice. Userid, one created at, update det, access the post's user. Post.user.name equals Alice. Access all of Alice's posts. User.posts.count equals 1. User posts first title equals Alice's first post. Create another user and post. Bob equals user create name. Bob email, bob@example.com. Bob posts create title. Bob's amazing article content, this is a great read. Find a post by its ID and then its user. Post find, one.user.name equals Alice. Find a user by their ID and then their posts. User find, two.posts.count equals 1. Notice how clean and intuitive the syntax is. User posts gives you a collection of post objects, and post.user gives you the associated user object. Rails handles all the underlying database queries automatically. Cascading deletes, dependent. Destroy. What happens if you delete a user? By default, the posts she created will still exist in the database, but their user ID will be orphaned, pointing to a non-existent user. This is usually not desired. You can modify the has-many association to automatically destroy associated records when the parent is deleted. app/models/user-rb. Class user, application record. Has-many posts dependent. Destroy hash if a user is deleted, their posts are also deleted. And there are other dependent options like delete more performant but bypasses callbacks, or nullify sets foreign key to nil. Choose destroy if you need associated callbacks to run, like deleting images associated with the post. What's next? You've significantly enhanced your application's robustness and data modeling capabilities. You learned how to implement validations in your models to ensure data integrity and how to display those errors to users on forms. Crucially, you've mastered associations, enabling you to define and effortlessly navigate relationships between your different models, a cornerstone of any meaningful web application. With this solid foundation in data handling, the next logical step is to manage access to that data. In Chapter 10, we'll delve into user management, specifically focusing on robust user authentication, who is this user? And basic authorization, what can this user do? We'll introduce a popular gem that simplifies this complex task. Chapter 10, User Management, Authentication and Authorization Basics. In the previous chapters, you've built a functional blog where users can create, view, and manage posts. However, anyone can currently do anything. To make an application truly useful and secure, you need to know who is using it and what they are allowed to do. This takes us to the concepts of authentication and authorization. Authentication. This is the process of verifying a user's identity. Who are you? E.g., username and password, social login. Authorization. This is the process of determining what an authenticated user is permitted to do. What are you allowed to see or modify? E.g., only logged-in users can create posts. Only the post's owner can edit it. Implementing authentication and authorization from scratch can be a complex and error-prone endeavor, involving secure password hashing, session management, password resets, and more. Thankfully, the Ruby on Rails ecosystem provides excellent tools to simplify this. Introducing Devise, the go-to authentication gem. For authentication in Rails, the Devise gem is the de facto standard. It's a flexible authentication solution that handles common requirements like signing up, user registration, signing in, logging in, signing out, logging out, password recovery, sending reset instructions, email confirmation, verifying user email, and much more. Devise is a modular solution, meaning you can pick and choose the authentication features you need for your application. It integrates seamlessly with active record models. Before we start, a word of caution. Working with user authentication involves sensitive data, passwords. While Devise handles much of the security for you, always follow best practices. Never store plain text passwords, use strong encryption, and keep your software up to date. Let's integrate Devise into our application. Step 1. Add Devise to your gemfile. Open your gemfile in the root of your application and add the following line. Gemfile. Gem Devise. Then, run bundle install in your terminal to install the new gem. Bundle install. Step 2. Run the Devise install generator. Devise comes with its own generator that sets up necessary configuration files and helps you integrate it. Rails generate Devise install. This command will create an initializer file, config/initializers/deviserb, where you can configure Devise settings. Add instructions to your config/environments/developmentrb for email setup, for things like password resets, which you'll need to configure a mail server for in a real application. Add a root path note, which we've already done. But if you didn't, it would guide you to set up your root. You'll see output with suggestions. One important one is to ensure you have a root path defined, which we already set in Chapter 4, e.g. root pages #home. Step 3. Create the user model with Devise. To make your user model, app/models/user-rb, work with Devise, you run another generator. Rails generate Devise user. This is incredibly powerful. This generator will Modify your app/models/userRB file to include devise, database authenticatable, registerable, recoverable, rememberable, validatable. These are modules included by devise to provide the authentication features. Create a migration file, e.g., db/migrate/yimtums sdevice create usersRB, with all the necessary columns for your user's table, e.g., email, encrypted password, reset password token, etc. Now run the migration to add these columns to your user's table. Rails DB, migrate. Self-correction for audiobook suitability. Mention explicitly that the existing user model will be modified and its name and email attributes already exist, but new columns like encrypted password will be added. This avoids the listener thinking we're creating a brand new model from scratch. Let's adjust our app/models/userRB file slightly. If you created your user model with name and email earlier, the devise generator would have updated userRB to app/models/userRB. Class user, application record. Add these devise modules. Devise, database authenticatable, registerable, recoverable, rememberable, validatable. Any associations previously defined should remain. Has many posts dependent, destroy. And devise will now handle the email field for authentication. You can choose to keep the name attribute if you want to store a display name for the user, separate from their email. Step 4. Add devise links to your layout. For users to sign up and log in, they need links. We'll add these to our application HTML layout file so they're accessible on every page. Open app/views/layouts/application HTML and add the following code, perhaps in the body section, before the yield statement. P-class equals notice % equals notice %p. P-class equals alert % equals alert %p. P % if user signed in. % hello % equals current user email %. % equals linkto edit profile, edit user registration path %. % equals linkto sign out, destroy user session path data, turbomethod. Delete %. % else %. % equals linkto sign up, new ser registration path %. % equals linkto sign in, new ser session path %. % end %. P % equals yield %. Here's what these helper methods do. User signed in, a devise helper that returns true if a user is currently logged in, false otherwise. Current user. If a user is signed in, this helper provides access to the logged in user object. Edit user registration path. The path to the edit profile page generated by devise. Destroy user session path. The path to log out. The data. Turbomethod. Delete is important for modern Rails because logout should be a delete request, and this attribute tells Turbo, Rails' default front-end accelerator, to convert the link click into a delete request. New ser registration path, the path to the sign-up page. New ser session path, the path to the sign-in page. Restart your Rails server Rails S. Now, on every page, you'll see sign-up and sign-in links. Once you sign up and log in, these will change to hello, your email, and sign out. Try it out, click sign up, fill out an email and password. Once signed up, you should see hello, your email. Click sign out. Devise provides many default views for registration, login, etc. You can customize these views if you want to change their appearance by running Rails generate devise views. Step 5. Protecting controller actions, authentication. Now that we have users, we want to restrict certain actions to only logged-in users. For instance, only a logged-in user should be able to create, edit, or delete posts. Devise provides a simple before-action filter for this. Authenticate user. Open app/controllers/posts-controller-RB and add the following line at the top of the posts-controller class, after the class. Application controller line. App/controllers/posts-controller-RB. Class posts-controller, application controller. Before-action authenticate user, except. Index, show, #redirect to login if not signed in. Before-action, set post only. %I, show edit update destroy. #rest of your controller code, end. Before-action, authenticate user. This tells Rails to run the authenticate user method provided by devise before every action in posts controller. If a user is not signed in, they will be redirected to the login page. Except, index, show. We use except to specify that the index, list all posts, and show, view a single post. Actions do not require a user to be logged in. This makes sense for a public blog where anyone should be able to read posts. If you wanted to protect all actions, you'd remove except. Now, if you try to go to posts new or posts one edit without being logged in, Devise will redirect you to the sign-in page. Basic authorization, what users can do. Authentication tells us who the user is. Authorization tells us what they are allowed to do. For example, any signed-in user might be able to create a post, but only the owner of a post should be able to edit or delete it. We can implement this basic authorization logic directly in our posts controller. Associate posts with the current user. When a post is created, we need to associate it with the currently logged-in user. In posts controller #create, modify the line where the post is built. #app/controllers/posts-controller-rb. # in the create action. Def create. # instead of at post equals post new, post params. At post equals current user posts new, post params. # builds a new post associated with current user. If at post save, redirecto at post notice. Post was successfully created. Else, render new status, unprocessable entity. And, since we defined has many, posts on user and belongs to, user on post, current user posts new correctly sets the user id for the new post. Restrict edit update destroy actions to owners. Now, let's add a before action to ensure only the owner can modify a post. #app/controllers/posts-controller-rb. Class posts controller, application controller. Before action authenticate user, except. Index show. Before action set post only. %I show edit update destroy. Before action correct user only. %I edit update destroy, #add this line. # all your existing actions. Private. Def set post. At post equals post find params, id. And def correct user, # new method for authorization. Unless at post.user equals current user # check if the post's user is the current user. Redirecto post's path alert. Not authorized to edit this post. And def post params. Params require post permit title content. And with before action correct user only. %I edit update destroy. Before any user tries to edit, update, or destroy a post, the correct user method will execute. If the at post's user, its owner, is not the current user, the logged-in user, they are redirected with an alert message. This is a basic form of authorization using controller-level logic. For more complex authorization rules, e.g., roles like admin versus moderator versus regular user, you'd typically use dedicated authorization gems like pundit or can. These gems provide more structured and scalable ways to define permissions throughout your application. What's next? You've successfully implemented robust user authentication using the powerful Devise gem, enabling users to sign up, sign in, and sign out securely. You also added basic authorization to ensure that users can only manage their own content. These are fundamental building blocks for almost any real-world web application. With our core application features now in place, it's time to build confidence in our code. In Chapter 11, we'll introduce testing. You'll learn why testing is crucial for ensuring the reliability and correctness of your Rails application and how to write basic tests for your models, controllers, and even user interactions. Chapter 11, Testing Your Application, Building Confidence. You've built a functional Rails application with models, views, controllers, and even user authentication. That's a fantastic accomplishment, but as applications grow in complexity, ensuring everything still works as expected becomes challenging. What if a change you make in one part of the code breaks something seemingly unrelated elsewhere? This is where software testing comes in. Testing your application is like having an automated quality assurance team. You write code that verifies other code, ensuring that your application behaves correctly. It's a core practice in modern software development and brings immense benefits. Confidence in changes. You can refactor code, add new features, or upgrade Rails versions with less fear of introducing regressions, new bugs, and old features. Bug detection. Tests catch bugs early, often before they even reach a user or a staging environment. Documentation. Well-written tests describe what features are supposed to do, serving as living documentation. Design feedback. The act of writing tests can often highlight poorly designed code, encouraging you to write more modular and testable components. Rails embraces testing, providing built-in tools and conventions to make it a natural part of your development workflow. Why test? Imagine you're building a complex machine. You wouldn't just assemble it and hope it works. You test individual components, then subsystems, and finally the whole machine. Software is no different. Manual testing, clicking through your application in the browser, is slow, prone to human error, and doesn't scale. Automated tests run quickly, consistently, and repeatedly, allowing you to rapidly verify your application's health. Rails default testing framework, Minutist. When you create a new Rails application, it comes configured with the Minutist framework. Minutist is a lightweight, fast, and full-featured testing framework that integrates tightly with Ruby and Rails. You'll find your test files in the test directory of your application. Tests in Rails are organized by the part of the application they are testing. Test models. For testing your active record models and their validations, associations, and custom methods. These are often called unit tests. Test controllers. For testing how your controllers respond to requests and interact with models and views. These are sometimes called integration tests or functional tests. Test system. For simulating user interactions in a real browser, like clicking buttons, filling forms. These are system tests or feature tests. Test fixtures. Placeholder data that your tests use when running against the database. Test/application system test case RB and test/test helper RB. Configuration files for your test environment. Running your tests. To run all your application's tests from the terminal, simply navigate to your application's root directory and type Rails test. You can also run tests for a specific file, Rails test/models/postist_rb, or even a specific test within a file, Rails test/models/postist_rb, and test title must be present. Writing model tests, unit tests. Model tests focus on the business logic defined in your active record models. They verify validations, callbacks, associations, and any custom methods. When you generated your post model, Rails automatically created test/models/postist_rb. Let's open it and add a test for our title presence validation. First, let's create a fixture for posts. Fixtures provide sample data for your tests. Open test/fixtures/postSyml and add a sample post. Test/fixtures/postSyml. 1 title, MyString. Content, MyText. User, 1 hash associate with the 1 user fixture, if you have one. Self-correction for audiobook suitability. Clarify that fixtures are YAML files and how they work. Now, open test/models/postist_rb. Test/models/postist_rb. Require test helper. Class post-test active support, test case. Hash this sets up a user fixture named 1 that we can use. Fixtures, users hash ensure you have a test/fixtures/user_yml with at least one user, e.g. 1. Name, John Doe. Email, john@example.com. Test, post title must be present due. Post equals post new content. Some content, user. Users, 1, hash create a new post without a title. Assert not post valid. Post should not be valid without a title hash assert that the post is not valid. Post title equals a valid title, hash add a title. Assert post valid. Post should be valid with a title hash assert that it is valid. And test, post title must be at least 5 characters long due. Post equals post new title. Short content, some content, user. Users, 1, assert not post valid. Post should not be valid with a short title. Post title, long enough title. Assert post valid. Post should be valid with a long enough title. And test, post belongs to user due. Post equals posts. 1 hash uses the 1 post fixture. Assert nil post.user. Post should have a user association. Assert kindoff user, post.user. Post.user should be an instance of user. And explanation. Require test helper, brings in the Rails test environment. Class post test active support, test case. Your test class inherits from active support, test case, which provides a lot of testing machinery. Fixtures, users. loads the data from test/fixtures/user_xml into the database before each test. Users 1 gives you access to the user object created by the one fixture. Test post title must be present, do, end. Each test method is an individual test case. The string argument is a descriptive name. Assertions. Minutist provides various assert methods to check conditions. Assert not post valid, checks that post valid, returns false. Assert post valid, checks that post valid, returns true. Assert not nil post.user, checks that post.user is not nil. Assert kind_user post.user, checks that post.user is an instance of the user class. If you run Rails test/models/post_b now, you should see all your new tests passing. Writing controller tests, integration functional tests. Controller tests verify that your controller's handle requests correctly, interact with models as expected, and render the right views or redirect. Rails automatically creates test/controllers/posts controller to *b. Let's add a test to ensure an unauthenticated user cannot create a post. Test/controllers/posts controller to *b. Require test helper. Class posts controller test action dispatch. Integration test. Setup do. At post equals posts. 1 hash load a post fixture for reuse. At user equals users. 1 hash load a user fixture. And test should redirect new post if not logged in do. Get new postural hash try to access the new post form. Assert redirected new sessional hash, expect redirection, to login pay. And test should not create post if not logged in do. Assert a difference, post.count, do hash asserts that post count does not chain. Post postcirl, params, post title new test post content, test content. And assert redirected new sessional hash, expect redirection, to login pay. And test should create post if logged in do. Signin at user hash helper provided by devise for testing. If you added the necessary test helpers. Assert difference, post.count. 1 do hash asserts that post count changes by exactly 1. Post postcirl params. Post title logged in post content, test content user id. At user id. And assert redirected postural post last. Hash expect redirection to the new posts show paid. And test should not destroy post if not authorized, do. Hash assuming user 1 created the post, and we're trying to destroy it as another user. At other user equals users. 2 hash load another user fixture. Signin at other user. Assert a difference post.count, do. Delete postural, at post, hash try to delete as the unauthorized user. And assert redirected postcirl, hash expect redirection back to posts with alert. Assert equal not authorized to edit this post. Flash alert hash check the flash message. And action dispatch, integration test. Controller tests inherit from this. Setup do, end. This block runs before each test method, allowing you to set up common conditions like loading fixtures. Get new postural simulates a GET request to the post's new path. Assert redirected checks if the request resulted in a redirect to the specified URL. Assert a difference, post.count, do, end. This block asserts that the count of post records in the database does not change after the code inside runs. Assert difference, post.count, 1 do, end, asserts that the post count increases by 1 signin at user. This is a helper specific to devise to simulate a logged-in user in your tests. You'll need to define it in your test/testhelper_rb or test/controllers/testhelper_rb. For testhelper_rb, add include devise, test, integration helpers inside active support, test case class. Flash alert allows you to check the value of the flash message that was set in the controller. These tests simulate a user's interaction with your application at the controller level, verifying the correct responses and permissions. Writing system tests feature tests. System tests, introduced in Rails 5.1, allow you to test your application by simulating a user's full journey through a web browser. These are best for testing end-to-end features, including JavaScript interactions. They use Capybara, a browser automation tool, under the hood. Rails provides test/application system test case RB for configuration. Let's test signing up and creating a new post. Test/system/posts to *b. or create a new file if it doesn't exist. Require application system test case. Class post test application system test case. Setup do at user equals users, 1 hash load a user fixture. And test signing up and creating a new post, do. Visit new registrational hash, go to the sign up page. Fill in email with test@example.com. Fill in password with password. Fill in password confirmation with password. Click in sign up. Assert text welcome, you have signed up successfully. Hash look for the success message. Hash now create a post. Visit new postural. Fill in title with My System Test Post. Fill in content with Content from Automated Test. Click in Create Post. Assert text post was successfully created. Hash verify post creation message. Assert text My System Test Post. Hash verify title appears on show page. And explanation. Visit navigates the browser to the specified URL. Fill in fills in a form field with the given text. Click in clicks a button or link with the given text. Assert text checks if the specified text is present on the page. System tests are slower to run than model or controller tests because they launch an actual browser. But they provide invaluable confidence that your user-facing features work as intended. Test-driven development, TDD, brief concept. While we've written tests after implementing features, many developers advocate for test-driven development, TDD. In TDD, you write your tests before writing the code that fulfills the requirement. The TDD cycle, red-green refactor, is red, write a failing test for a new feature or bug fix. Green, write just enough code to make the test pass. Refactor, improve the code's design while ensuring tests still pass. TDD encourages writing small, focused tests and clean, modular code. What's next? You've learned the importance of testing in Rails and how to write different types of tests. Model tests for business logic, controller tests for request handling, and system tests for full browser simulation. You understand the tools Rails provides and how to interpret test results. Implementing tests from the start will save you countless hours of debugging and give you peace of mind as your application evolves. It's a hallmark of professional software development. With our application now robust and well-tested, we can look at enhancing the user experience. In Chapter 12, we'll explore modern front-end techniques within Rails, specifically Hotwire, Turbo, and Stimulus, which allow you to build rich, interactive user interfaces without the complexity of traditional JavaScript frameworks. Chapter 12, Enhancing the User Experience, Hotwire, Turbo, and Stimulus. Up to this point, our Rails application has primarily used a traditional, server-rendered approach. When a user clicks a link or submits a form, the browser makes a full-page request to the server, and the server sends back a brand new HTML page. This is straightforward and very effective. However, modern users expect highly interactive experiences, often resembling mobile apps, where parts of the page update without a full reload. For a long time, the dominant solution for this was to build a separate single-page application, SPA, using a JavaScript framework like React, Angular, or Vue, which would then communicate with a Rails API. While powerful, this approach adds significant complexity. You're essentially building two separate applications, a front-end and a back-end, that need to communicate and be deployed independently. Rails 7 and newer versions of the framework offer a compelling alternative that brings back the simplicity of server-side rendering while delivering rich, app-like interactivity. Hotwire. Reframing the problem. HTML over the wire. Hotwire stands for HTML over the wire. Its core philosophy is that HTML is powerful enough for most dynamic updates. Instead of sending JSON data to the client and having a JavaScript framework render HTML, Hotwire sends rendered HTML snippets over the network and replaces specific parts of the page with them. This leverages Rails' strengths in server-side rendering and minimizes the amount of custom JavaScript you have to write. Hotwire is a suite of complementary technologies. The most important ones for our purposes are Turbo and Stimulus. Turbo, supercharging page navigation and updates. Turbo is the workhorse of Hotwire. It enhances the speed and interactivity of your application without requiring you to write custom JavaScript. Turbo intelligently intercepts navigation events, like link clicks and form submissions, and handles them with a combination of browser history management and partial page updates. Turbo consists of several modules. 1. Turbo Drive, faster page navigation. Turbo Drive, formerly Turbolinks, speeds up page navigation. Instead of a full page reload, Turbo Drive intercepts navigations from link clicks A and form submissions form, prevents the browser from making a full request, makes an AJAX request without interrupting the user's current page, renders the server's response, swaps the body of the old page with the new, and merges the head sections. This means your page content updates, but shared elements, like head content or even background JavaScript, persist, providing a faster and smoother user experience closer to SPA, but with very little effort. Turbo Drive is included by default in new Rails 7+ applications and works automatically. You might not even notice it, but your app will feel faster. 2. Turbo Frames. Updating specific parts of a page. Turbo Frames allow you to declaratively define regions of your page that can be updated independently without a full page reload. This is incredibly powerful for creating dynamic forms, comment sections, or even modal dialogues. Imagine we want to add a status to our post model, e.g., draft, published. Instead of a full page reload on update, we want just the status to change. First, let's add the status column. Rails generate migration add status to post status, string. Then Rails DB, migrate. Set a default value in your model for convenience. Default valuefer status, draft. Now, in our app/views/posts/show_html, let's wrap the status display in a turbo frame. %#app/views/posts/show_html%. h1% equals at post title %h. P. Strong status /strong. % equals turboframe tag domid at post. Status do %. % equals render post/status badge post. At post %. End P. P% equals at post.content %p. % equals linkto edit post path at post %. % equals linkto back to posts path %. And create the partial app/views/posts/status badge html %#app/views/posts/status badge html %. Span % equals post.status.capitalize %span. % equals linkto toggle status post path post data. Turboframe domid post status turboction. Replace if post.user equals current user %. We'll add a custom route, an action to posts controller to handle the status toggle. Config/routes rb. Resources posts do. Member do. Patch toggle status. End app/controllers/posts controller rb. Class posts controller, application controller. Hash other actions and before actions. Def toggle status. At post equals post find params id. If at post status equals draft. At post update status published. Else at post update status draft. And render partial post/status badge locals. Post at post status OK #render partial back to the frame. And hash other private methods end. Explanation. % equals turboframe tag domid at post status do %. This helper creates a turboframe HTML element with a unique ID generated by domid. Any link or form submission within this frame that targets the same frame ID will cause only that frame to update, not the whole page. Data, turboframe, domid post, status, turboction. Replace. This tells the link to update the specific turbo frame. When the toggle status post path is visited, the server renders only the status badge partial, and Turbo replaces the content of the post status frame with this new HTML. The toggle status action now renders only the partial, and Turbo knows to slot it into the correct frame. 3. Turbo Streams, real-time updates from the server. Turbo Streams allow your server to push HTML changes to the browser in real time, typically over WebSockets, though they can also work with FormWidth and Linkto by responding with text/VND Turbo Stream HTML. This is perfect for features like live comments, notification feeds, or follow buttons. Imagine you have a comments section. When a new comment is created, you want it to appear instantly for all users viewing that post. To use turbo streams over WebSockets, you typically set up a channel using Action Cable, Rails WebSockets framework. In your view, subscribe to a stream. %app/views/posts/show_html perhaps below comments section %. % = turbostream from, post comments #at post ID, %. In your comment model, broadcast changes. #app/models/commentarb. Class comment, application record. Belongs to post. Belongs to user. After create a comment, broadcast dependo, post comments #post ID, target. Comments partial. Comments comment locals, comment self. And this broadcast dependo method, provided by Turbo to Active Record models, automatically sends a turbo stream that appends the comment HTML partial, rendered with the new comment, to the HTML element on the page with the ID comments. When a new comment is created, the server automatically broadcasts the new HTML, and it appears on the page for everyone connected to that stream without needing a page refresh or custom JavaScript. Stimulus, adding modest JavaScript behavior. While Turbo excels at HTML manipulation, sometimes you need client-side interactivity that involves more specific JavaScript. This is where Stimulus comes in. Stimulus is a modest JavaScript framework that works by connecting HTML elements to JavaScript controller classes using data attributes. It's designed to be complementary to server-rendered HTML. Stimulus doesn't generate HTML, it stimulates it. It observes changes to the HTML DOM, document object model, and executes JavaScript when specific data controller attributes appear or data action attributes are triggered. Imagine we want to toggle a Show More button for long content. Create a stimulus controller. Rails generate stimulus toggle. This creates app/javascript/controllers/toggle-controller.js. app/javascript/controllers/toggle-controller.js. Import controller from @hotwire/stimulus. Export default class extends controller. Static targets, content, define a target to interact with. Connect. This runs when the controller is connected to the DOM. Console log, toggle controller connected. Toggle. This .content target class list toggle. Hidden, toggle a CSS class. Add data attributes to your HTML. %#apps/views/posts/show_html. Div data controller equals toggle. P data toggle target equals content, class equals hidden. This is some very long content that you might want to hide, unless the user clicks Show More. P button data action equals toggle #toggle show more button. Div style/simple CSS for demonstration. Hidden display none. Style explanation data controller equals toggle. This attribute connects an HTML element to the toggle controller JavaScript class. Data toggle target equals content. This attribute marks a specific element, p tag, as a target that the stimulus controller can easily reference, e.g., this .content target. Data action equals toggle #toggle. This attribute tells stimulus to execute the toggle method within the toggle controller when the button is clicked. When you click Show More, the content is hidden or revealed by stimulus manipulating its CSS class without involving the server. The power of Hotwire, Turbo plus Stimulus. The combination of Turbo and Stimulus allows for incredibly rich user experiences with minimal JavaScript. Turbo handles page changes and partial updates by sending HTML over the wire. It keeps the server-side render first philosophy. Stimulus adds interactivity and client-side logic to those HTML elements after they are rendered by the server or updated by Turbo. This workflow is incredibly productive. You write most of your application logic in Ruby on the server, leveraging Rails power. For the interactive bits, you use a small, predictable amount of JavaScript with Stimulus. This keeps complexity down compared to full SPA frameworks while delivering modern UI expectations. What's next? You've now seen how Rails leverages Hotwire, Turbo, and Stimulus to bring dynamic, app-like experiences to your web application without the overhead of building a separate JavaScript front-end. This approach keeps your development workflow efficient and your codebase coherent. With our application feature complete and interactive, the final step for a fully functioning web application is to make it accessible to everyone. In Chapter 13, we'll delve into deployment, taking your amazing Rails application and putting it online for the world to see. Chapter 13, Deployment, sharing your application with the world. You've poured your efforts into building a fantastic Rails application. You've organized your data with models, handled interactions with controllers, made it look good with views, secured it with authentication, and even added dynamic elements with Hotwire. Now, the moment of truth, deployment. Deployment is the process of taking your application from your local development environment, your machine, and putting it onto a web server where it can be accessed by anyone with an internet connection. This transforms your local project into a live, public website. The journey to production. What does putting it online actually mean? It involves several key steps and considerations. Server setup. Your application needs a server running 24/7, accessible via the internet. This server needs to have Ruby, Rails, a web server, like Puma or Passenger, and a production-grade database, like PostgreSQL or MySQL, installed and configured. Code transfer. Your application's code needs to be moved from your development machine to the production server. Version control, Git, is indispensable here. Dependency installation. All the Ruby gems specified in your gem file need to be installed on the production server. Database configuration and migration. Your application needs to connect to the production database, and any pending migrations, Rails DB, migrate, must be run to set up or update the database schema. Asset compilation. For better performance, Rails compiles and minifies your JavaScript, CSS, and other assets into optimized files. Environment variables. Sensitive information, like API keys, database credentials, should not be hard-coded into your application code. Instead, they are stored as environment variables on the production server. Web server interface. A web server needs to be configured to route incoming web requests to your Rails application. This might sound like a lot, and historically, setting up production servers, often called DevOps, was a complex task requiring specialized knowledge. However, modern cloud services and platforms as a service, PaaS, have greatly simplified this for developers, allowing you to focus on writing code. Deployment options for beginners. For your first deployments, focusing on a platform as a service, PaaS, is highly recommended. PaaS providers abstract away much of the underlying server management, allowing you to deploy your Rails application with just a few commands. They handle maintenance, scaling, and much of the complex server setup. Two popular and beginner-friendly PaaS options are Heroku, a long-standing, very popular PaaS known for its ease of use. It has a free tier, though it may involve dyno sleeping, where your app temporarily idles if not accessed. Render, a newer, increasingly popular PaaS that offers a generous free tier for static sites and databases, with competitive pricing for web services. It's often seen as a modern alternative to Heroku. While the specifics might vary slightly between providers, the general workflow remains consistent. We'll use a generic PaaS approach that applies to both. Pre-deployment checklist before pushing to a PaaS. Before you deploy, there are a few important steps to take in your Rails application. Choose a production database. SQLite is excellent for development, but it's not suitable for production. It's a file-based database, meaning it doesn't scale well and isn't designed for concurrent access by multiple users. For production, you'll typically use PostgreSQL, the most popular choice for Rails applications in production due to its robustness, ACID compliance, and rich feature set. MySQL, another strong relational database option. Most PaaS providers offer a managed PostgreSQL or MySQL database service. You'll need to update your gem file to include the appropriate database gem, PG for PostgreSQL, MySQL2 for MySQL. For example, for PostgreSQL, hash gemfile, gem PG 1.0 hash add this line, hash remove or comment out, gem SQLite 3 for production group. Group development test do, gem SQLite 3 1.4, and then run bundle install. Commit all your code to Git. Git is your version control system. Your PaaS will often deploy directly from your Git repository. Ensure all your latest changes are committed. Git add. Git commit ready for deployment. If you haven't set up a remote repository, like GitHub, you'll need to do that and push your code there. PAS services typically integrate directly with GitHub GitLab repositories. Check your Gemfile lock. Make sure your Gemfile lock is up to date and committed. This file locks down the exact versions of all your gems, ensuring that the production server installs the same versions as your development environment. Review production configuration. Rails has different environments. In config/environments/production.rb, you'll find settings specific to how your application behaves in production, e.g., error reporting, eager loading classes. Generally, the defaults are good, but you might need to adjust things like email delivery settings for device in production. General PAS deployment workflow. While specific commands differ, the general steps for deploying a Rails application to a PAS like Heroku or Render are: Step 1. Create an account and a new application. Go to the PAS provider's website, e.g., heroku.com, render.com, sign up for an account. Create a new application or new service on their dashboard. Connect it to your Git repository, e.g., your GitHub repo. This allows the PAS to automatically deploy whenever you push changes to your main branch. Step 2. Configure environment variables. This is critical. Your database credentials, API keys, secretKYBASE, a Rails-generated secret for session management, and other sensitive information should never be committed to your Git repository. PAS providers give you an interface, often called config vars or environment variables, to set these securely. You'll need a secretKYBASE. You can generate one in your Rails console, Rails secret. Copy this value. Your PAS will provide you with database URL or similar automatically when you provision a database add-on. Add these variables through your PAS dashboard's configuration section. Step 3. Provision a production database. Most PAS providers offer managed database add-ons, e.g., Heroku Postgres, Render PostgreSQL. Add one to your application service through their dashboard. The PAS will then automatically make the database accessible to your Rails app via an environment variable like database URL. Step 4. Run database migrations on the server. Once your application code is deployed and connected to its production database, you need to set up the database schema by running your migrations. Most PAS providers have a way to run Rake or Rails commands remotely. For example, on Heroku run Rails DB, migrate. On Render, they might have an initial build command or a shell access feature where you type Rails DB, migrate. This step applies all the schema changes defined in your migration files to your production database, creating or updating tables. Step 5. Precompile assets. In production, Rails precompiles all your JavaScript, CSS, and image assets. This bundles and minifies them into optimized files, which improves load times for your users. Historically, you would run Rails assets, precompile. However, most modern PAS providers detect that your application is a Rails app and automatically build and precompile assets during the deployment process when you push your code. This process can add a few minutes to your deployment time. Step 6. Deploy. With your application configured, database set up, and assets precompiled, you're ready to deploy. If you connected your PAS to a Git repository, simply pushing your changes to the specified branch, like main, will trigger a new deployment. Git push origin main hash or your default branch. The PAS will then pull your latest code, install gem dependencies, run the asset precompilation. Optionally, run your database migrations, start your web server processes. After a few moments, your application should be live and accessible via the URL provided by your PAS. Post-deployment checks. Visit your app's URL, make sure it loads and looks correct. Check server logs. PAS providers offer tools to view your application's logs. This is invaluable for debugging any issues that arise after deployment, e.g., Rails log, production log. Create a user post. Test that basic functionality works on the live app. Monitor performance. Keep an eye on your PAS's metrics for server response times and resource usage. Important considerations: scaling and maintenance. As your application grows, you might need to consider scaling. If your app gets a lot of traffic, you might need more dynos, Heroku instances, render, or upgrade your server resources. Background jobs. For long-running tasks, e.g., sending emails, processing images, you'll use background job frameworks like Sidekick to offload work from your main web processes. Monitoring. Tools to track application performance, errors, and user behavior. Continuous deployment, CD. Automating the deployment process so that every time you push to your main branch, new changes are automatically deployed. Most PaaS platforms facilitate this. What's next? You've successfully deployed your Rails application. This is often the most rewarding moment for a developer, seeing their creation live on the internet. You now understand the basic steps and considerations involved in taking your code from your machine to the outside world, using the power of platform as a service providers. This book has guided you through the entire process of building a Ruby on Rails application, from understanding the language fundamentals to deploying a working web application. But the journey of learning and building never truly ends. In our final chapter, Chapter 14, we'll discuss continuing your journey. We'll cover resources for further learning, exploring more advanced Rails features, getting involved in the community, and charting your path forward as a web developer. Chapter 14, Continuing Your Journey, Beyond the Book. Congratulations! You've reached the end of this book, and more importantly, you've built and deployed your first Ruby on Rails web application. You've navigated the intricacies of Ruby, mastered the MVC pattern, grappled with databases and validations, secured your application with authentication, and even made it interactive with modern front-end techniques. This is a significant achievement and a testament to your hard work. But learning web development, much like the web itself, is a continuous journey. Technology evolves, new best practices emerge, and your own projects will present fresh challenges and opportunities for growth. This final chapter is about pointing you towards the vast resources available and suggesting pathways for deepening your expertise and contributing to the vibrant Rails ecosystem. The Rails community, your greatest asset. One of Ruby on Rails' enduring strengths is its active, supportive, and passionate community. You are not alone in your learning or your struggles. Official Rails guides, the definitive and authoritative source for Rails documentation. If you have a question about a specific Rails feature, start here. guides.rubyonrails.org. Stack Overflow, a treasure trove of questions and answers. Chances are, if you've encountered a problem, someone else has too, and the solution is already there. Search for Ruby on Rails related questions. Active Ruby and Rails forums communities. Websites like devdo, reddit.com/r/Rails, and the official Rails mailing list, or newer platforms like Discord servers dedicated to Ruby Rails, are great places to ask questions, share knowledge, and stay updated. Local meetups and conferences. Many cities have local Ruby or Rails user groups. Attending these, even virtually, is a fantastic way to network, learn from experienced developers, and get inspired. Major conferences like RailsConf are excellent for in-depth learning and community connection. Twitter Mastodon, X/Bluesky users. Many prominent Rails developers and community members share insights, tutorials, and news on these platforms. Following them can keep you in the loop. Don't be afraid to ask for help, but also practice the skill of searching for solutions first. Explaining your problem clearly and showing what you've already tried is key to getting good answers. Exploring more gems. The Ruby Gems ecosystem is enormous, containing tens of thousands of reusable libraries, gems, that extend Rails functionality. Some gems have become near standards in the Rails world due to their utility. Active storage, for effortless file uploads, images, documents to cloud services like Amazon S3, Google Cloud Storage, or Azure Storage. Action text, for integrating rich text content into your Rails models with simple image attachments. Action cable, Rails framework for integrating WebSockets, enabling real-time features like chat and live updates in your application. We touched on this when discussing turbo streams. This is the underlying technology. Sidekick, for running background jobs. When you have long-running tasks, like sending thousands of emails, processing large files, or interacting with third-party APIs, you don't want them to block your web requests. Sidekick allows you to push these tasks into a queue to be processed asynchronously. RSpec, an alternative testing framework to Minitest that offers a more behavior-driven development, BDD style for writing tests. Pundit/can. For more sophisticated authorization rules than we built in Chapter 10, enabling role-based access control, e.g., administrator, editor, normal user. PostgreSQL/MySQL gems, PG MySQL2. As discussed in deployment, these are essential for using production-grade databases. Dotan Rails. For managing environment variables in development, separate from your main configuration. When choosing a gem, consider its popularity, maintenance status, and compatibility with your Rails version. Advanced Rails topics to explore. This book covered the fundamentals. Here are some areas where you can deepen your Rails expertise. API development. Learning how to build a Rails API that can power a separate JavaScript frontend, like a React app or mobile applications. Rails has an API mode for this. Performance optimization. As your application scales, you'll need to learn about database indexing, caching strategies, page caching, fragment caching, object caching, efficient database queries, and debugging performance bottlenecks. Security best practices. Beyond strong parameters and CSRF tokens, understanding common vulnerabilities, SQL injection, XSS, and how Rails helps prevent them. Debugging techniques. Mastering the debugger, like binding pry or biobug, and effective log analysis. Advanced Active Record. Digging deeper into complex queries, scopes, custom validations, and callback chains. Service objects and POROs, plain old Ruby objects, for encapsulating complex business logic that doesn't fit neatly into a single model or controller, promoting a cleaner codebase. View components, a new approach to building reusable, encapsulated UI components in Rails, bridging the gap between traditional views and front-end frameworks. Contributing to open source. One of the most enriching experiences for a developer is contributing to an open source project. This could be fixing a bug in Rails itself, contributing to a popular gem, or improving documentation. It's an excellent way to learn from experienced developers, get your name out there, and give back to the community that supports you. Start small, perhaps by clarifying a documentation error or suggesting a minor improvement. Career paths for Rails developers. The skills you've acquired building applications with Ruby on Rails are highly valuable in the tech industry. As a Rails developer, you might pursue roles such as backend developer, focusing primarily on the server-side logic, APIs, and database interactions. Full-stack developer, comfortable working across the entire stack, from front-end user interfaces to backend development and database management. DevOps engineer, specializing in optimizing deployment pipelines, server infrastructure, and application monitoring. Product manager, with technical background, leveraging your understanding of how web applications are built to guide product development. The demand for skilled Rails developers remains strong, particularly in startups and companies that value rapid development, elegant code, and maintainable systems. Your ability to quickly prototype, build, and deploy functional applications makes you an asset. Final thoughts: keep building, keep learning. The most effective way to learn and grow as a developer is to keep building. Don't stop with the blog application from this book. Think of other ideas you have and try to implement them. The next project might be a simple task manager, a recipe app, or a community forum. Each new feature you attempt will push your understanding further. Embrace problem solving. When you encounter an error, see it as an opportunity to learn. Search for solutions, read documentation, and don't be afraid to experiment. The world of web development is constantly evolving, and maintaining your skills requires continuous learning. Stay curious, engage with the community, and enjoy the immensely rewarding process of bringing your ideas to life with code. You are now a Ruby on Rails developer. Go forth and build amazing things.